अच्छा। ठीक। जी सर। अच्छा ठीक है सर, हम दिखवा लेते हैं।
Hello, 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 Jyoti sir.
Hello.
Yeah,
Yes.
am
Okay.
I
Okay,
audible?
Naveen. So, good afternoon,
Okay.
Naveen.
Yeah, good afternoon, sir.
Good afternoon. So, good to see you. So, good afternoon, everyone. Good afternoon, participants. So, welcome to the last day of this faculty development program. So, we have our today's speaker, Dr. Naveen Saini. So, Dr. Naveen Saini is currently an assistant professor at Andokot College of International Studies and researcher at 4IR Applied Research Center, Wungsung University. Please excuse me, Naveen, if I am not pronouncing the name properly.
No, it's okay. It's okay. Yeah.
Republic of Korea. So his research interest includes clustering algorithm, natural language processing, information retrieval and extraction, evolutionary algorithm, and multi-objective optimizations. He was a postdoctorate researcher at University Talazau 3 Paul Sabatier, France, and before that, he earned his PhD from Indian Institute of Technology, Patna. So, welcome, Dr. Naveen, and thank you for joining today. And now I'll request you to please start your presentation, your
Yeah.
talk.
Yeah. Thank you, Professor, for handing over the session to me. Okay. So let me share my slides. Yeah. Is it visible to all?
Yes, yes, it's visible.
Okay. Okay. So hello everyone. Sir has already introduced me about me. So regarding the topic, I am going to cover multi-objective based cross-language summarization for low resource language. So this topic is consisting of the four different things. First one is the multi-objective. Second thing is the cross language. Third thing is the summarization. And the fourth thing is the low resource language. So I will introduce them briefly and then I will cover one of the recent approach for the cross language summarization. So maybe you know what is summarization. Summarization is creating automatically creating a compressed version of the text document. Here, text document can be a set of tweets, it can be the web page, single document, multiple document, or maybe some web document. So many things are there. The summary should be like that. It should cover the main idea of the text and it should be non-redundant. That means the sentences in the summary should not be similar to each other. So regarding the constant, like how many words should be in the summary. So there are different empirical study in the literature. So one of the studies says that the summary should not be not longer than half of the original text and usually significantly less than that. It is one of the empirical study in the literature. So there are another empirical study in the literature regarding the NIST conferences. So they are saying that the summary should be approx 250 words, not longer than 250 words, 250 words. But nowadays, so this constant is keep on extending because we have the lot of blogs, very long article. If we want to summarize those long articles into the 250 words, maybe we will not be able to get the main idea of that blog. So that's why. So there are so many shared tasks going on for the long summary generation that is around 600 words. So why we need the summarization system? Because we are reducing the document size. So if document is size is maybe 2000 words and you are presenting a summary in the within 200 words, that is reducing the document, or you can say you are compressing the document. Second advantage is it is able to cover the theme and central idea of the document. Third advantage is active reading. Obviously, when you are providing a summary to the user for a long document, so it will gain the user interest. User will actively read that document. For example, in the newspaper also, so most of the user focusing on the headlines, not only the content, to see the overall idea. So that is increasing the user interest in reading the summary. It's called, you can call it as active reading. Fourth thing is that decision making process. You can make the fast decision after getting the central theme of the document. And last advantage is it helping saving in the time. If I will provide you a long document, maybe you don't have the enough time to read that document. But if I will provide you the summary, then it will obviously save your time. Now, there are different categories of the summaries. First one is the extractive, and second category is the abstractive. Extractive means selecting a few relevant sentences from the original document. So here, instead of sentences, there can be phrases, or say maybe there can be paragraphs. So let's understand this extractive summarization using an example. So here, a document is there consisting of 4 sentences. Sentence 1, sentence 2, 3, and 4. So here, extractive summarizer is extracting the sentence 2 and sentence 4 based on their relevance. So here, relevance means like their importance with respect to the entire document. So there are different features for calculating the relevance. Like one relevance feature can be the similarity of the sentence with the title of the document. Another relevance feature can be the position of the sentence in the document. So there are too many features out there, and we can calculate the sentence scores based on different features. On the other hand, in case of the abstractive summarization, it includes the words and phrases different from the one occurring in the source document. For example, so here again same document is there consisting of 4 sentences. So here task is to construct new sentences, or in other words, you have to reconstruct the original sentences in a few words. So we can also can understand in another way, like, so here we have given a set of sentences. We need the knowledge of natural language understanding and how to generate the text from the by after understanding the text. So maybe you heard about the natural language generation, understanding and the generation. So it's a very important concept in the natural language processing. So this abstractive summarization need that concept to generate the new sentences. So here I have shown an example using the English sentences. So this is a document consisting of different sentences, and after generating the summary, you can see the colored sentences excluding the blue color. are extracted based on their relevance. This is just for example. So they are copied as it is in the summary. In case of the abstractive summarization, so you can see a long sentence is there. So this sentence is reconstructed into a smaller sentences. So you can see the highlighted words. So they are the important words. So that sentence is constructed using these highlighted words. So nowadays, there is a third variety of the summarization, like you can say compressive summarization. So people are thinking, what is compressive summarization? So it is actually not a purely a extractive summarization or not abstractive summarization. You can say it's a midway between the extractive and the abstractive. In other words, it selects a few relevant sentences from the original document and then compress sentences by removing the non-relevant words. For example, so it can be the single sentence compression or multi-sentence compression. So for example, suppose in the summary, we have two sentences. Okay, two sentences, they are similar to each other. Just for it is just for an example. The sentences in the summary should not be redundant to each other, but I have taken the redundant sentences for just for an example. So there are two sentences almost similar to each other, and we are fusing the both the sentences into a single sentence by taking the common words. So this is the like a compression. We are removing the non-relevant part in the sentences. Now coming to the technique used. So in literature, for to solve the summarization problem, different type of techniques are developed, including supervised. So supervised techniques require training level data. That means if you want to summarize document, then we need the document summary pair for the training purpose. In the unsupervised technique, there is no need of level data. For example, we can apply the k-means clustering technique, or there are too many unsupervised approaches to summarize a document. Third category is the meta-heuristic based method. So meta-heuristic based method are based on some optimization strategy. So they may be supervised and or unsupervised. So I am going to cover one of the method based on the meta-heuristic approaches. And fourth category is the neural network based method. So again, it can be supervised or unsupervised. So there are different applications of the summarization. For example, we can summarize a single or multiple document, comment-oriented document summarization. For example, nowadays we have the document along with the comments from the different users. So we can summarize the document with the support of the comments. Figurative. For example, you want to summarize some figures in the biomedical article. So if time permit, I will go try to cover this figure summarization. Email based summarization. If you want to summarize the emails, thread of emails, because in the companies there are a lot of emails are there. They are like you can say thread of emails are there. So you can summarize those emails to get the idea. Sentiment based summarization, scientific document summarization, web based summarization. So there are too many summarization systems are there. So I have just listed a few of them. Now coming to the categorization of the summarization based on the languages. So first category is the monolingual. So it means developing an algorithm for the unilanguage version. It can be the English, Hindi, or maybe any other language. And the summary should be in the target summary should be in the same language as of the source document. Second category is the multilingual. It means transforming an algorithm or a set of resources from a monolingual to a multilingual version. Third category is the cross language. It means producing a summary in a different language than of a source document. For example, here the given document is in the Thai language, but the target is to generate the summary in the another language. So here English and the Chinese language is shown. So in today's lecture, I am going to discover cross-language summaries. Now, there are two possible scenarios for the cross-language summaries. So one like we have given the source language text, we can convert that text into the target language. For example, suppose source text is in the Hindi language, but we want to generate the summary in the English language. So what is the possibility? Convert the Hindi language to the English language. So here English is the target language, and then apply summarization algorithm, and that algorithm will produce the summary in the target language. So this method is called as the early translation method for cross-lingual summaries. That early translation means we are translating the source text into the target language before applying the summarization algorithm. Second possibility is, given the source text, we can apply the summarization algorithm and generate the summary in the source language. Suppose source language is Hindi. So after applying the summarization algorithm, we will get the summary in the Hindi. And then after generating the summary, we will convert that summary into the target language using some Google Translator or Bing Translator. So many translators are there. So these are the two possible scenarios. So in one of the study in 2011 or later in 2015, so it has been shown that to generate the cross-lingual summary using the early translation or the late translation method is not of the good quality. So that's why there is a need to think about how to generate a good quality of the summary to develop a cross-lingual summarization. So that's why a third way is also there. So given the source text, you can convert the source text into the target language using some translator. So I have shown you the Google Translator. You can use any other translator, and then apply summarization algorithm utilizing cross-language lingual feature. That means you are taking the benefit of the source language feature and the target language feature to generate the final summary. So in literature, it is already established that if we do the fusion of the early translation and the late translation method, then it helps in generating the good quality summary for the cross-lingual summaries. So how to do that? So I'm going to cover that part. So now I have covered first one is the summarization. Second concept is the what is cross-language summarization. So let me cover the brief about the multi-objective and the underrepresented language. Then I will cover complete, like I will integrate all the things to develop a framework. Now, what is low resource language? So when you think about Indian language, what comes in your mind? Maybe you can think, okay. So there are too many like different type of languages are there, like European, Indian language. In every country, there are some low resource languages are there. So what do you mean by low resource language that I'm going to cover? So this is the one of the map I have taken from the Wikipedia in terms of the language used by different countries. You can see in India, so in most of the part like Hindi and English. So there are other different varieties are also there, like Tamil but I have no I have taken this from Wikipedia. But it is a major part like Hindi and English, Chinese and Arabic. So many countries are there. They have their own language. So this is the map of India where I have shown the different languages spoken by the different peoples of different states like Hindi, Gujarati, Marathi, Telugu, and Kannada, Tamil. So if you can see even for the Hindi language, there are different varieties are there. For example, in the Bihar, mostly Bhojpuri and Magdi is there. Then second language is the Maithili, Urdu, Bengali, and Santali. So there are different variety of the languages, even for the Hindi. The Chandigarh, Hindi, Punjabi, Urdu, Nepali, Bengali. So there are different versions of the language. So even I belong to suppose Haryana, and I want to maybe want to travel to some Hyderabad city. So they are speaking in their language. So I am not able to understand. So if there is some system is there, cross-lingual system, then I can summarize the document in their language in my target language, or which can be easily understood by me. So that will be help me to understand the brief idea of the conversation, you can say. So actually, what do you mean by low resource language? So the low source language are those languages for which very few resources exist, or very few computational data resources exist. Very less data exist online to do the some experiment for the experimental purpose. On the other hand, high resource language are the language for which there are many data resources existing, making possible for the development of machine learning based system. So you already know that English is by most well-resourced language in all the countries. English is the, you can say, globally recognized language. Now, what is the motivation to develop a cross-lingual lingual summarization system? So in our multicultural world, when peoples are moved increasingly, that means when peoples are moving from one country to different country, it is common to live in a country without understanding its vernacular language, and thus being unable to access most of the relevant online resources such as news. For example, if I am going to a different country, so in that country, it is possible that their resources like a news, or maybe their local newspaper, or maybe whatever information is available, that is available on in their language, and I'm not able to understand that language. So it is a very challenging task for the non-native speaker to read those documents to extract the useful information. also the media industry that serves them lack an appropriate tool for generating cross-lingual some information. So for and also for the English speaker, the Foreign Service Institute, it's a government agency in the US. They have provided the list of hardest to the lowest language learning ranking around the world. So I want to say that if I'm going to from one country to the another country, so it may be possible that if I will try to learn their language, so it can take a lot of time to learn. So this US agency, government agency, have provided the list of languages from the hardest to the lowest language. So you can see, so for example, in the category 1, it includes Afrikaans, Danish, Dutch, French, Italian, Norwegian, Portuguese, Romanian, Spanish studies. So it takes around 23 to 24 weeks to learn. So it is a like consuming most of time to learn. So we cannot waste their time when we are going from one country to another country. Therefore, there is a need to build a system for handling cross language for the non-native speaker. So obviously we can use some translator to understand their document, but again, that document may be too large to understand the idea of the document. Therefore, that's why there is a need to develop the cross-language summarization system. So recently, there is a project in the European government like NVIDIA. So Europe includes approx like many countries. So therefore, they are targeting to develop a cross-lingual system for the summarization and so many translator and so many things they are developing under the NVIDIA project. So coming to our theme was to combine to develop a cross-language summarization for the low resource language. So till now, I have covered the briefing about the summarization, what is cross language, what do you mean by low resource language, or you can say less represented language. Now, how to develop a system? So here I will show an approach using the multi-objective evolutionary algorithm. Now, coming to the multi-objective optimization. What is this concept? Multi-objective optimization means trying to optimize more than two objectives simultaneously. For an example, on the left hand side, if a customer want to purchase a car and he is worried only about the cost, that means cost should be minimized. He's not worried about this comfortable or like any other things in the car, only worried about the cost. So that is the single objective optimization. But on the other hand, right hand side, if customer is worried about the less cost or more comfort, that means he is trying to optimize more two things simultaneously. So that is the multi-objective optimization. So let's take another example. In terms of the mathematical function, so there is a function f1 equal to x squared. So after drawing the curve, you can see if we want to minimize this function, so this function have the minimum value at x equal to 0. So for this problem, we have only the one minimum solution, which is the 0. But on the right hand side, we have the two functions, f1 and f2. So this is the blue line is the curve for the f1, and this red line is the curve for the f2. So if you can see, f1 has the minimum value at x equal to 0 and f2 has the minimum value at x equal to 2. So both are minimum at different value, which is 0 and 2 respectively. If we want to optimize both of them simultaneously, so it is very difficult to get a single optimal value. You cannot say 0 because f2 is not minimum at 0. You cannot also say 2 because f1 is not minimum at 2. But you can say the minimum value of the, when you are trying to optimize both these functions, you will get a set of value lying between 0 to 2. So that means when you are trying to optimize more than two objectives, you will get a set of solutions lying between some range, which is not the case in the case of the single objective optimization. Now coming to the meta heuristic technique, which is an evolution algorithm I have used in these slides. So evolution algorithms are inspired by the biological phenomena. For example, a solution in the nature, we are the individuals. So in the evolution algorithm, individuals are represented by a solution. Individual has the chromosomes and the genes, so they are represented using the representation of the solution and the component of the solution. I will show them. And population consists of the set of solutions, or you can say set of individuals. Darwin's theory, so I am simulating the behavior with the nature. Population is consists of the set of solutions in the evolution algorithm. So in the nature, we have the Darwin's theory. That means the solution which is good in terms of the fitness value, that will proceed to the next generation. So in the nature, between the individuals, we have the crossover and the mutation as a genetic operator to generate new children. So these are called as the search operator in the evolution procedure. And we have the generations. So this generation you can call it as a iterative procedure in the evolution. So you can see in this figure, so there are different generations are shown. So so you can see generation 1, 20, 80. So you can see it is following the Darwin's theory. The solution which is good in terms of the fitness value, that is proceeding to the next generation. You can see they are keep on dying, and only this solution is left at the final generation. And this figure denote the flow of the evolution algorithm. So we have the population consisting of individuals. These individuals will go through the crossover and the mutation to generate the new childrens, and then those children and the childrens again have the fitness value. They will proceed to the next generation if they are good in terms of the fitness value, and it will keep on continue until we get the optimal solution. So this is the flow chart I have shown. These are some set of solutions called as the population. Each solution is associated with some fitness value. So the again mating pool construction, that means parent selection will be there. So who will become the parents? Because these are the parents. I have shown by the circle, and then they will generate new solutions using the genetic operators. Okay, fine. I will explain what is meta heuristic. Let me complete this slide. So genetic operator means crossover and the mutation. So again, these solutions are associated with some fitness value, and then we will merge this new solution with the all population. So here all population is the original solutions, this one, which are associated with some fitness value, and these new solutions are also associated with some fitness value. So we will merge them, and then we will select top best solutions based on their fitness value. And finally, we will update the population. So you can see this black boundary box. So they have replaced the previous solutions. Now this iteration will continue until we get the optimal solution. So I have received a question in the chat box. What do you mean? What is meta-heuristic approaches? So meta-heuristic approaches are based on some you can say they are some optimization procedure. So they utilize some heuristic in the nature. For example, or you can say they are randomized in nature based on the random behavior. So for example, if we want to generate the new solutions here using the genetic operators, if we want to generate new solutions, so there are two concepts, crossover and the mutation. So these operations are based on some probability. You can say if probability will be greater than 0.8, then crossover will be performed, otherwise mutation will be performed. So you can say you are guiding the you are using some heuristic in this procedure. And why meta heuristic? Because you are keep on optimizing the solutions based on their fitness values. So that's why these algorithms are called as the meta heuristic approaches. I hope that this term will be clear to you. Now there are so this is the one of the algorithm differential evolution under meta heuristic approaches. So there are too many approaches are there, like non-dominant sorting algorithm, differential evolution, particle swarm optimization, so many algorithms. So it is one of the algorithm that is a differential evolution. So for the presentation, we have used the binary differential evolution. That means binary version of the differential evolution. So where we'll deal with the binary space, because our aim is to select a subset of the sentences from the original document. That's why we are dealing with the binary space. So this is the same flow like population initialization, fitness evaluation, and then maximum number of generation. We will continue. For each solution, we will construct the mating pool, then generate some probability estimation operator. Here, this operator, so for example, so it will generate the, so suppose there are two solutions, solution number 1 and the solution number 2, and we want to generate the new solutions. So what we have to do, first we have to apply the probability estimation operator. So what it will do, so it will generate the so it will generate some probability value for each component of the solutions. After generating the probability value, so you can see we will convert that probability value into the into the binary space. For example, if the probability value of for some component is greater than some random probability, then we will put 1, otherwise 0. So in this way, we will convert that solution into the binary space. After that, we will perform the crossover operation, and then we will evaluate the fitness for that for the new solutions, and then we will add the new solution to the list. So after generating the new solution for every solution, what we will do, we will merge the old population. We will initialize the population with the new population, and then we will select the top best solutions in terms of the fitness value, and we will keep on continue until we will get the and we reach the maximum number of generations. So this is the flow chart: initialize population, then fitness evaluation, and then maximum number of generation, new solution generation, fitness evaluation, update population, and continue until we get the set of Pareto optimal solutions. Now coming to the problem statement of the cross language summarization. Given a set of source document, so I'm talking about the low resource language because we have the because we are dealing with the low resource language, we have the very less resource for these type of languages. So given a set of source document, the task is to select a subset of sentences of the target language, English. Okay, we are the here source document and the target languages are different from each other in the cross lingual system. So given a source set of source document, our target is to select a subset of sentences in the target language such that three objectives, which is the anti-redundancy. Anti-redundancy means the redundancy between the there should not be redundancy between the sentences in the summary. So it is one of the objective. Second objective is the mutual information between the source and the target language. So this objective capture the linguistic feature between the source and the target language. And the third objective is the maximum length of the sentences. So in the literature, it has been shown that if sentences is longer, so it may give the relevant information, but that is not always true. But it can be the true. So obviously, it depends upon the document to document. So third objective is the maximum length of the sentences. So our task is to optimize these three objectives simultaneously using the multi-objective binary differential evolution framework. So this is the you can see in the terms of the mathematics, given a set of n document, m is the number of sentences in the summary, and this is the maximum length constraint in the summary. It may be 250 words, 100 words, depending upon the data set. So let's call this framework as a CLTS, cross language text summarization system using multi-objective evolution. Now coming to the first step, because we are dealing with the binary space, so we are representing the solutions. So here population initialization means we have to initialize the solutions in the binary space. So this is the one of the solution I have shown in the binary space 1001010, and the 1 2 3 4 5 6 7, these are the sequence of sentences in the document. So here the first position, this one means this first sentence should be in the summary. 0 means the second sentence should not be in the summary, and so on. So we will initialize the solutions in the binary space randomly. And please note that the summary length constraint should be satisfied. Suppose the number of sentences, the solution should not exceed the summary length constraint. For every solution, we will calculate three objectives. Psi 1, you can say objective, this is the objective 1, objective 2, and objective 3. So we are maximizing these three objectives simultaneously. So this is the first step of the evolution approach, initial population. So the number of words corresponding to the sentence present in the solutions should not exceed the maximum number of words allowed in the summary. And in every solution in the population representing a summary and associated with three objectives, objective 1, objective 2, and objective 3. So in the next step, we will to evaluate objective functions. Now coming to the definitions of the objective functions. First is the anti-redundancy. So as I discussed, the summary should not be redundant. The sentences in the summary should not be similar to each other. So here what we have to do. So so here a solution is representing the summary. So what we are doing, we are capturing the similarity between the sentences in the summary. So it may be the cosine similarity, it may be the maybe other like word over distance, normalized Google distance. So many similarity measures are there. So we will calculate the similarity between between the all pairs of sentences in the summary divided by total number of pairs. So this is one of the objective functions, and our task is to maximize it. So why maximize? Because to capture the similarity, we are utilizing the word over distance means if can say if two text are two sentences are exactly similar, those similar their similarity their word over distance should be 0. If the word over distance between the two sentences is more than 0, that means you can say they are non-similar to each other. Okay, that's why we are trying to maximizing this feature. Now coming to the second objective, this is the most important objective for the to develop a cross-language summarization. So as I told you, if you will perform the early translation or the later translation to develop a cross-language summarization, the summary quality is not so good. But if we capture the information from the source language and the target language, then it helps in generating the quality of this. So what we are doing, we have the source language, we are converting into the target language. So you can see these are the set of sentences in the source language, and corresponding set of sentences in the target language. So what we are doing, we are calculating the similarity between the different sentence pairs. For example, we will calculate the similarity between the I and jth sentence in the target language and the same sentence in the source language, and will multiply them. So this is represented by Kij. So this is the similarity between the two sentences, and it helps in capturing the information from the source language and the target language. So why the maybe you have the question like why multiplication is there, square root. Again, there is an empirical study to study about why, like what is the effect of the plus sign, minus sign, or the square root. And after analysis, it has been observed that if you will multiply the similarity between the ith and the jth sentences in the different languages, then this helps in producing the good quality of the summary. And this Kij, so this is the similarity between the source sentences. You can say SR representing the source, and here Kij raised to the power TR, that means target language. So it is the similarity between the I and jth sentences of the target language. Here I and j should not be similar, should not be the similar sentence. Okay, we will assign Kij to this similarity if I does not equal to j, otherwise 0. So after evaluating the similarity between the different sentences pair in the source language and the target language, what we will do, we will calculate the relevance of the is sentence using this similarity. For example, in the source language, we will assign some score to every sentence. So KSR, I already told you this is the KSR. This is normalization symbol plus this KSRTR. That means the similarity of the source language sentences with the target language sentences. This KSRTR is the this equation. and alpha beta are the some you can say weightage, and their summation should be 1, and u and v are the silence score of the sentences belonging to the target and the source language. So in this way, we will assign the relevance score to different sentences in the source language. Also, we will assign scores to the different sentences in the target language. Now, our target is to maximize this relevance score. This relevance score, you can say summation. So every solution, every solution we have a set of sentences, and every sentence has some relevance score using the source language, the target language. So we will sum up all the scores of the sentences to calculate the sum, and we want to maximize this core-rank score. So why core-rank? Because we are capturing the information from the source language and the target language. So this is the third objective we have taken into the consideration, maximum length. That means we want to maximize those sentences which are maximum in length. So length here li means ith sentence in the summary. So here all the sentences belonging to the summary. Okay, so we are calculating all the objective for every solutions. Now coming to the third step, new solution generation. For the new solution generation, again what we will do, for the current solution, we will pick up the 3 random solution R1, R2, R3 from the population, and then we will perform some arithmetic operations. So this is B is a constant, B is a scaling factor, and F is a scaling factor, and R1, R2, R3 are some random solutions from the population. So this step is called as the mutation step. So what it will do, it will generate the probability value for each component of the solution, and then we will convert that solution into the binary space using some randomized procedure. After that, we will apply some crossover probability. That means if crossover probability is greater than some random probability, we will keep the component of the new this new solution. Otherwise, we will keep the component of the original solution for which we want to generate the new solutions. Now, after generating the new solution for every solution, what we will do, we have the old population, we have the new population. We will combine the population. After that, after combining the population, we will arrange the solutions based on their ranking. For example, so this is the rank 1 solution. These are the rank 2 solutions. These are the rank 3 solutions. So here example is shown for maximizing 2 objectives, F1 and the F2. So here you can see the solution A and B are non-dominated to each other. Why? Because solution A, because we are maximizing both the objectives. So here you can see solution A, and comparing solution A and B, solution A is better in terms of the F2 value as comparison to B. But solution B is better in terms of the F1 value as comparison to F2. So that's why both are non-dominated to each other. So similarly, on comparing A, B, C, D, so all are non-dominated to each other. But if you want to compare solution A and the F, so here you can see solution A is dominating solution F. Why? Because in terms of the F1 and the F2 value, solution A is better than solution F. That's why solution A is dominating F. Solution A is dominating solution F. So in this way, we have ranked the solutions based on their dominated and non-dominated procedure. So we have the 3 rank solution, rank 1, rank 2, and the rank 3. So after ranking the solution, what we will do, we will pick up the best solutions. For example, we can pick up the rank 1 solution or rank 2 solutions. Now it's up to you how many solutions you want to proceed for the next generation. So maybe you want to proceed with the these 4 plus this 1 solutions, maybe 5 of solution, or maybe you want to proceed with the 6 solution in the next generation. So it's up to you.
Please
So
explain
we will,
this concept
yeah,
of non-dominating and dominating.
yeah.
Please explain
Should
it
I?
again. Yes.
Okay, okay, fine. Okay, fine. So here we have a set of solutions, right? So what we will do, we will rank the solutions. So maybe I can maybe show some more slides. So I thought that Sripadna madam has already covered this concept. Let just wait. Let me show you some more slides. Yeah, is this visible?
Yes.
Yeah. Okay. Suppose these are the some solutions in the two-dimensional space. Solution 1, 1, 1, solution 2. These are the objective functions value. 1, 1, 1, 2, is 3, 1, 2, 3, and 4, 2. So you can see these solutions are representing in a two-dimensional space. Now, what we will do, so here you can see these solutions. Let me come into the concept. So here there is a one algorithm called as the non-dominated sorting. So what it will do, it will divide the population into the k fronts. K fronts. So in the increasing order, for example, F1, F2, and Fk. So we are considering Fn as the rank 1 front, rank 2, and rank 3, and you can say rank K front. So if we, for example, so here in terms of the mathematical formulation for solution I and solution J belonging to the particular front Fk. So I am talking about the non-dominant sorting. Then I will discuss how to sort them. So in every front, in a particular front, for all solutions, solution I should be non-dominated to solution J. And for all solutions belonging to particular front K, there exists a solution belonging to Fk1 such that solution dash belonging to Fk1 dominate solution belonging to Fk. So this is the mathematical definitions. So let me come to the how to sort them. So here can you see so to apply the non-dominated sorting, so what we have to do, we have to store two things. So you can see for solution 1, so can you tell me, like, for the solution 1, so we want to minimize, right? We want to minimize. So let me copy the value. It will help you. So these are the solutions. So you can see this solution 1. Solution 1 is 1, 1, right? So we want to minimize. So you can see solution 1. So in terms of the fitness value 1, that means first objective value. So it is better than solution 2, solution 3, solution 4, solution 5. Okay, and but equal to the objective function value for the solution 2, right? On the other hand, if you will compare the second objective function value, you can see it is better than this objective function is better than solution 2, solution 4, and solution 5. So here, what is the concept? So here, this solution 1. So how many solutions are dominating to solution 1? So you can see how many solutions are dominating to solution 1. So you can see those are solutions. So every solution, this solution is better than all the other solutions. This solution is better than all the other solutions. let me explain again. So let me compare solution 1 and 2. So in terms of the objective function 1, so both have the similar value. Okay, so we cannot decide. But in terms of the objective function 2, solution 1 is better than solution 1. So that means we can say solution 1 is dominating solution 2. Let me compare solution 1, this one. Yeah, let me compare solution 1 and the solution 3. So in terms of the first fitness value, so here again solution 1 is better. You can see solution this first fitness value, the solution 1 has the 1 value, and but solution 3 has the 3 value for the objective function 1. But for the second objective function, both are equal. Okay, so you can see this function as this solution 1 is again better as comparison to the solution 3. Okay, now let me explain the solution 4 and 5, this one. So in terms of the first objective function value, solution 4 is better because this is minimum. 2 is minimum than 4. But in terms of the second objective function value, solution 5 is better than solution 4 because 2 is minimum than 3. So here, in terms of the first objective function value, solution 4 is better, but in terms of the second objective function value, solution 5 is better. So you can say solution 5 and 4 is non-dominating to each other. So is it clear? Should I explain again?
Yes, clear.
Okay, fine. So let me go back to the slide.
But the term front is still unclear. Dominance
Okay.
and non-dominance is clear, but the term front is not clear.
Okay, fine. So in this way, you will arrange the solution. You can calculate how many solutions. So here you can see n solution. So for every solution, we will calculate two things. So n solution means how many solutions are dominating to solution 1. So here you can see solution 1 is better than all other solutions. Or you can say no solution is dominating solution 1. So that's why we will put 0. That means no solution, the number, it is representing the number of solutions dominating solution 1. So that is 0. And S sol 1 means, so how many, so which, what are the solutions which are dominated by solution 1? So you can say solution 1 is dominating solution 2, solution 3, solution 4, and the solution 5. So for every solution, we will calculate this type of information. So after calculating this information, so we have this table, right? So this is the table. So can you tell me which solution has the 0 count? That means how many solutions are dominating solution 1? So there is only one solution which has the 0 domination count, right? 0 domination count. That means no solution is dominating solution 1, or we can say this is way of rank 1. So we will put that solution 1 into the rank 1 solutions. Okay, please notice that we want to minimize both the objectives. So we will put this solution into the rank 1 solutions. So here, after putting this the rank 1 solution, so what are the, so yeah, any questions? Any questions up to here? What are the rank 1 solutions?
No.
Okay, fine. So after putting the rank 1 solutions, now we have to see what are the solutions which can be into the rank 2 solutions. So what we will do, so you can see this is the information about the solution 1. So here you can see solution 1 is dominating solution 2, solution 3, solution 4, and solution 5. So after putting the solution 1 into the rank 1, so we can exclude this solution from the competition because we have already kept this into the one of the front. So now what we will do, whatever solutions are there in this list, SOL1, solution 2, solution 3, solution 4, and solution 5. So what we will do, we will decrease their domination count. So you can see in the previous slide, the domination count of solution 2 was 1, like original information, 1, 1, 2, 3. Now what we will do, we will decrease the domination count by 1. So it will be 0. Now coming to the solution 3, again it will be 0. We will decrease by 1. Coming to the solution 4, it was previously 2. We will decrease by 1. It will be 1. And for the solution 5, it is 3. So solution 5 is in the list. So we will decrease the domination count by 1. Now it will be 2. Now by observing this table, we can see, so there are two solutions, solution 2 and solution 3, which have the 0 domination count. So we can keep them into the second rank solutions, okay? Or you can say second front. They will be in the second front, or you can say they are of rank 2. So after doing this, so this is the last table. So n solution 4 is equal to 1 and n solution equal to 2. So now what we will do, so in the solution 2 and the S solution 3, we have the solution 4, solution 5, and again solution 5. So we have this information. Now what we will do, we will decrease the domination count. So here N solution 4, it was previously 1. So we will decrease the domination count by 1 because there is a solution 4. Now for solution 5, what we will do, previously it was 2. We will decrease it by 1. Now again there is a solution 5 in this list, right? So we will again decrease its domination count by 0. Now in the final stage, what we are observing, we have the solution 5, right? Solution 5. So what we will do, we will put it into the rank 3 solutions, or you can say, what we will do, we will put the so what we have the two solutions, solution 4 and the solution 5, which have the domination count 0. So what we will do, we will put these two solutions into the rank 3 solutions. So this is the front 3. So is it clear now how to calculate the different rank of the solutions?
Yes, yes.
So here here in this figure, you want to minimize both the objectives. So solution with is of rank 1 solutions, highlighted by red color circle. So solution 2 will be of rank 2, and solution 4 and 5 will be of rank 3. And you can notice that the solutions belonging to a particular front will be non-dominating to each other. So solution 4 and 5 are in a particular front, therefore they should be non-dominating to each other. You can also see, so here solution 5, in terms of the objective 1, it is in terms of the objective 2, solution 5 is better, but in terms of the objective 1, solution 4 is better than solution 5. So you can say both are non-dominating to each other. Similarly, you can see the front 2, solution 2 and 3 are non-dominating to each other. So this solution is of high, you can say, most important to each other. You can say this is the Pareto optimal solutions. Okay, so in this way we will arrange the solutions based on their non-dominance and the dominance criteria. We will arrange there into the different fronts. So let me move back to the slide. Yes, so here we will apply the non-dominating and dominating and the non-dominating criteria to arrange the solution into the different fronts. After that, we will select the best solutions, and after that, so it will become the new population for the next generation. So there is another important concept here, which is the crowding distance. For example, in the next generation, suppose if you want to take 5 solutions, okay, for the next generation. So you can take the 4 solutions from the rank 1, but from the rank 1, rank 2, which one to take, it is a difficult task because solution E and F are non-dominated to each other. So which one to choose? So to choose a solutions, so here, if you want to choose, yeah, any questions? Okay, so if you want to choose a particular solution in a particular front, then you have to use the concept of crowding distance operator. So the crowding distance operator will take that solutions. Yeah, any questions? Okay, so crowding distance operator will take that solutions which lie in less crowded region. So that is the main concept we are having, the crowding distance operator. So in this way, we will capture the take the best solution for the next generations. So finally, we will update the population. We will update the population, and then we will again update the population, and then we will again generate new solution, fitness evaluation, update population. This will continue, and at the end of generation, we will get the set of Pareto optimal solutions. And from those Pareto optimal solutions, for example, here A, B, C, D are the Pareto optimal. Suppose this is the graph obtained at the end of final generations. So A, B, C, D are called as the Pareto optimal solutions. From this Pareto optimal solution, we can pick up the best solutions to report the summary. Now coming to the data set. So for this cross-lingual summarization, we have utilized the a multilingual pilot 2011 dataset. So this is the dataset released as a part of shared task, but now it is openly available in different language. So multilingual 2000. So it consists of different topics, and under different topics, there are different documents like document 1, document 2, and document 10. Similarly, for the other topics. So for every topic, there are 3 goal summaries. So each summary is consisting of 250 words, and it is also provided in the English. So what we are doing, so we have the English version, okay, original data set. But for our cross-lingual summarization, what we are doing, we are converting the English language to the other language using the Google Translator. For example, French, Estonian, and maybe some other languages are there. And we want to generate the summary in the target language, which is our target language is the English version. So we will convert the English data set into the other language, and then we will try to generate the summary using that language to the in the English language. So for our purpose, we have utilized the Finnish because this work is done as a part of NVIDIA work. So for the purpose, we have used the Finnish, Croatian, Estonian, Slovenian, Spanish, Portuguese, and French. These are the used as a source languages, and the target language is kept as the English because that is globally recognized. So these are some results for the different language pairs. So first language pair we have used the Estonian English. So Estonian is the source language and English is the target language. So here Rouge 1, Rouge 2, Rouge L, Rouge SE4. So R means Rouge. So Rouge is a evaluation measure generally used in the summarization system. So what it will do, it captures the number of overlapping words between the generated summary and the actual summary, or you can say gold summary, overlapping words. One means it is calculating the number of 1 gram overlapping words, 2 gram overlapping words. L means longest common sequence. SU means skip gram, okay, by skipping some of the words. So for our purpose, we have generated the, because it is very difficult to choose the best set of objective functions for a particular task. So there are different variety of objective functions. So we don't know which one is better. So that's why average study is also done here. So you can see we have optimized three set of objective functions: objective 1, objective 2, and objective 3. And again, we have generated the summary in the extractive way and the compressive way. This is the objective. We have run the algorithm for that other combinations also. For example, objective 1 and the objective 2, objective 1 and the objective 3. And these are the different root scores. And this is the comparative study with the existing method. So you can say this is the same fusion method, core-rank method, CCLTS. So the, CCLTS.MSc, this is the compressive approach developed in the year 2020. And this is the core-rank method. This is the extractive method. Again, these both are the extractive. So we are comparing with the extractive and the compressive. So here you can see this, our approach like CLTS MEA is performing better than the other algorithm like same fusion, core-rank, and the CSCLTS. Okay, and in most of the cases, this extractive approach is performing better than the other compressive method. Similarly, this is the different results for the considering the Croatian and English pair and Slovenian and the English pair. Again, this CLTS MEA is performing better than the other approaches for both
Can
of the
you
versions.
can you give some idea explanation that why this technique of CLTS has performed better? Means what factors do you think that
Okay,
other
okay, yes.
techniques didn't consider?
Okay, okay, fine. So here, let me explain that this recent method cclts.msc. So this method, so it is the first thing is that it is based on the not on the optimization strategy, also to calculate the different sentence relevance. It is calculating one of the feature. For example, I explained you the core-rank feature, which is calculating the mutual inference between the source language sentences and the target language sentences. So this factor is using the only one relevance only one sentence relevant feature for generating the summary. So that, but our framework is simultaneously optimizing the different features or simultaneously. So that is the main advantage. And again, this core-rank method. Again, this method is again based on the single sentence relevance feature. Okay, so it is also calculated. And yeah, one more thing. This CCLTS.MSc method is a compressive based method and utilize the integer linear programming for the optimization. But our method is based on the multi-objective optimization concept and simultaneously optimize different objectives to generate the summary. So that is the main advantage over the other methods. So this is the other pair like Finnish and English for the two and report. These are the some rules measures. So here again, extractive method is performing better. These are the Portuguese and the English pair and the Spanish and the English sentence. Again, the CLTS method is performing better than other methods. And this is the Finnish and the English language. Finnish is the source and English is the target language. So this is the comparative study. Yeah. And this is the, because there are different data sets, and you know, an algorithm may perform well on one data set but may not perform well on the another data set. So what we have done, so we have averaged the all the root scores corresponding to different language pairs like Estonian English, Slovenian English, Finnish English, different language pairs, and then plotted a bar chart. So you can see like 1 plus 2 plus 3, that means we are simultaneously optimizing the three objective one, and these are the two objectives. So we are reporting the best one, and these are the some existing method. So again, by calculating the so root score, as I already explained. So root score measure the number of overlapping words between our generated summary and the actual summary. So actual summary is already available with the data set, but we are not using it while developing the while running the algorithm. Okay, we are just using the gold summary only for the evaluation purpose. So here, this is the average root score over all the data sets. So again, it is you can see the these bar chart, like first for these bars are giving the good performance over the existing methods. See SimFusion, ScoreRank, and the CCLTS.MSE. So MSE means multi-sentence compression. So I have given one example. So for all the other cases, our method is performing better. So this is the average ranking. So the because again, in for different data sets. So our in some for one data set, our algorithm giving good Rouge one score, but maybe Rouge one score is good, but not Rouge two score may not be good for the other data sets. So it varies for different data sets. Okay. So therefore, what we have done, we have again averaged all the Rouge scores and then rank the methods based on their highest Rouge score. So here, for example, this is the average Rouge score over all the data set. So this is the highest Rouge score obtained in terms of the Rouge one. So therefore, it is assigned as rank 1. It is at rank 2, rank 3, similarly rank 4, rank 5. So this is the ranking of the average Rouge score, Rouge 1 scores, and this is the ranking of Rouge 2 scores average over all the data sets. This is the ranking of Rouge SU4 scores over average over all the data set. Now to see which method is giving the better results. So what we are doing, we are performing the averaging of the ranks. For example, Rouge 1 rank in terms of the Rouge 1. So this method with the extractive summary generation is performing better. So what we are doing for this method, we are doing the 1 plus 2 plus 1. So and then we are taking the average. So average rank is 1.133 and its average rank is 4.33. Similarly, we have computed the average rank. So after observing the rank, we notice that this CLTS MEA method, that is our method, where we are optimizing the three objective functions simultaneously to generate the extractive summary. So it is giving the better Rouge scores. So this is the overall study in terms of the ranking of the methods. So these are some improvements obtained over the recent method, which is CCLTS.MSE. Cross-language text summarization using multi-sentence compression. So for the Estonian English, improvements are 3.19, 12.4, 7.51 in terms of the Rouge 1, Rouge 2, and Rouge SU1 respectively. For the Croatian English, improvements are 1.89, 1.43, and 3.08%, and similarly for the other language. So you can see these are some of the improvements obtained over the existing. Now coming to the readability. So readability is a very important factor for the very important factor. Okay, like for example, if I will provide you a summary, whether it can be readable by some user or not. Okay, so if we want to best readability can be done only by the human beings. But this is not possible in the real time. So a user can give some different scores to the summary. For example, whether the summary is correct in terms of the grammaticality, whether the summary is good in terms of the cohesion, in terms of the readability, or there are different factors to assign some readability score to a summary. But as I told you, in real time this is not possible. That's why there is a need to think a method how to measure the readability of the summary. So what we have done, so by assuming that the summary should be like a story, okay, the next sentence should be related to the previous one. So we are assuming this thing. So by assuming this factor, so this readability factor is designed which calculate the similarity of the previous sentence with the next sentence. Okay, obviously we have optimized the anti-redundancy functions which capture the measure the dissimilarity between the different sentence. But in terms of the readability, we are measuring how much similarity is there between the previous next sentence with the previous sentence. So I and I plus 1. I plus 1 is the next sentence and I is the previous sentence to for the previous sentence of I plus 1. So in this way, we have calculated the readability factor for the all the sentences in the summary. And then we have plotted the curve after computing this, including the existing methods, CCLTS, CoRank, and the other method. So here we can see that in terms of the readability, this CLTS method, our method is performing better. But again, for different language pair. So you can see this Croatian English, Estonian English. So here you can see this violet color. That means CLTS compressive. Okay, compressive. This is one of the method. Okay, so this method is performing better. But in terms of the Estonian English, you can say this red mark. That means CLTS MA, compressive CoRank. Okay, so let me explain you this, what is the meaning of this this thing. So here you know, like one more thing I want to explain in the readability factor. So in the before calculating the readability factor, what we have done, we have arranged the sentences of the summary in different orders. For example, so you can see position and the CoRank. Okay, so in the final summary, what we are doing, we are arranging the sentences in the summary in the similar order as they appear in the source document. Another way of arranging the sentences is the CoRank method. That means we are arranging the sentences of the summary based on the CoRank score. That means the sentence which has the highest relevance means after computing the score, considering the both the language pairs, source language and the target language. So we have arranged the sentence considering the CoRank score. The sentence which has the highest CoRank score, that will be at position 1, or you can say that will be the first position in the summary, and the sentence which has the second highest CoRank score will be at the second position at the summary. So in this way, we have considered different arranging orders in the summary, and after that we have computed the readability factor. So here we have you can see that for this language pair, this violet that means CLTS method, that means the compressive summary. So we are generating the two type of summary. One is the compressive summary, one is the extractive summary. So compressive summary is performing better with the position feature. That means if we will arrange the sentence using the position feature, then this summary, readability of this summary is better. On the other hand, for this Estonian and English pair, you can see this red color, okay, red color or this orange color, both are similar. For this orange color, you can see extractive summary is better utilizing the core rank feature. That means if you will arrange the sentences based on the core rank feature, then this summary is better. Okay, so similarly for the different language pairs, we have computed the readability score, and we come to know that, so depending upon the different languages, so CLTS method is performing better than overall performing better, but the arrangement of the sentence, the feature which is used for the arrangement of the sentences, so this feature is different for every language pairs. For this first language pair, this position feature is better. For this Finnish English language pair, this core rank feature is better. This Slovenian English pair, again this core rank feature is better. So different language, the ranking of the sentence or arranging of the sentence based on some feature, so that is different for every language. So in this way, we have studied this readability study. So this is some example analysis. So as I told you, for every topic, there are 3 reference summary. So this is the one of the reference summary in the English language. This is the reference summary 2. This is reference summary 3. Okay, so I have enclosed in the bracket to separate them by boundary. And this is the extractive summary generated by our system. So as I told you, we have generated the summary based on the position. So this is the, for example, this is the summary. So this sentence appearing at the first position in the original document. That's why this is at the first place in the summary. Okay, so this is the summary. So this is the arranging of the sentences based on the core rank score. Actually, both summary are the same, but arranging of the sentences are different. And the last one, we have combined the position and the core rank score. The sentence which has the highest position and the core rank score, that will be at in the rank 1 in the summary, or you can say first position in the summary. So in this way, we have considered 3 way to arrange the sentences, and they reported the score. And this is the existing method, like core rank method and the CCLTS. We have because their code is openly available, so we have run their code again. So this is the their summary generated. Okay. So this is my end of the lecture. So these are the some set of references. So if you have any questions regarding the cross language summarization, please let me know. Any questions?
Sir, I have a question, sir.
Yeah.
Sir, in case I am working with, I'm actually working with speech. So for low resource languages, the speech summary, the speech to text is not at all efficient. So it has a lot of errors. So how to tackle
Yes.
the problem when there are many text errors in case of cross-lingual summarization? So for example, suppose I have Bengali and Assamese. So Assamese right now does not have a good ASR to my knowledge. Bengali has, but Bengali also has the state-of-the-art ASR of Bengali is not really like efficient in that sense. Like there are so many word errors. So if I
Okay.
in this kind of a situation, both of them being low resource language, what do you suggest how I should tackle that problem?
Okay. So can you tell me which medium you are considering for converting the speech to text?
Sir, right now I'm using the Google Cloud Speech Recognizer.
Okay. Okay, fine. So in
Yes,
that
sir.
situation, so you can adopt the same framework, like as I discussed. So obviously, if you want to summarize something, you have to convert the speech to the text. Okay. So for example, you are speaking Bengali. So obviously, like you have to convert the speech to the Bengali text.
Right.
After that, you can suppose Bengali is the source document, so you can convert the source document into the target language. For
Right.
example, your target language is English. Okay,
Yes.
so you can use any language translator, maybe Bing translator, Google translator. So many translator is there,
Yes.
and I will suggest you, because every translator is not good. Okay,
Right.
so they have some like you can say ambiguity, or may every translator has some errors.
Yes.
They cannot translate everything. So what I will suggest you, just have a look on the document,
Okay.
because you know the target language, you know the English. So I will suggest you, after converting the speech to text, convert the document to the target language,
Right.
and just have a go through to the target language, whether the sentences are correctly translated or not,
Yes.
and then generate the summary using the cross-lingual feature.
Right.
Capture the information from the source language
Yes.
and capture the information from the target language. In this way, you can proceed.
Okay.
And I will suggest you to read the paper. There is a very old paper. This is a Corank method is there. Corank. Okay.
Okay.
So read that the method, because most of the people and the recent methods are there which are using that method in the recent method. Okay.
Right.
You can read them.
Right.
That will be better.
Sir, in case of so what it seems like, if there are ASR errors, like recognition errors from speech to text, suppose from Hindi to English, I want a summarization. In Hindi, I'm saying मुझे अभी निकलना है. So अभी मुझे अभी निकलना है is transcribed to something else. मुझे अभी and then निकलना is some other word and है. It's very it can happen for ASR of our languages, Indian languages. So if we get that text and then we convert it into the target language, say English, then there will be a huge performance drop in case of cross-lingual summarization. So
Yeah, I am getting a point. Yeah.
yeah.
So obviously, like I think there are many normalization method. For example, if for example in case of speech to, when you are converting the speech to the text, okay, so there may be wrong conversion of the speech to the text. Okay, so in that case, there are many normalization method to correct the mistake. Okay,
Okay.
or maybe I will suggest you to have a look. Okay, because your summary quality depend upon the original text, right?
Right.
So I will suggest to go through the text, or
Right.
maybe adopt some normalization method to correct the mistakes. Okay, so
Okay.
there are many papers are there, so you can adopt that.
Okay. Okay. Thank you so
Yeah.
much.
Okay, so any other questions?
Sir, so can we conclude that the answer to this question which have been asked is that ultimately either manually or using some normalization method that you have suggested, ultimately we will be requiring a data which is having least errors.
Yes. Okay.
Can we conclude this?
uh,
Means without having data which is not having the errors, we can't proceed to work upon Indian languages.
can you repeat? I am not getting it. Can you repeat the question?
I mean to say that the question which have been asked, because ultimately you have, I think you have suggested that we will be requiring either manually or maybe using some methods which have been available, that data set should be corrected first, only then we will be able to work upon it for some useful task.
Yeah, because every translator, whatever medium you're using, to the speech to the text, that may not be good. Okay, uh, he she explained me like one example. So the speech to the text is the wrongly translated into the text. So you have to adopt some normalization method, okay? Because human evolution is not possible at all. So that's why you have to either develop some your own method, or maybe adopt some a normalization method to correct the mistakes, and then you can proceed for the summarization.
Sir, if you have some time, it will give us more confidence. Indeed, you explained it very well about your work, but means if you can give show us some practical implementation of this work, that will be means really help us and make us confident.
Okay, okay. Okay, not now, but I have the like so I will share the link. Maybe I will share the link with the committee, so they will share with all the participants. So I have the code for the one of my work on the microblog summarization. So the same code I have adopted for this framework. So you can use that code. Instructions are also available on the GitHub. Okay, and maybe I can also share some instruction on the slides. Okay, to then you can run that code, and then you can adopt that code for this framework.
Okay, sir. So can we just share that GitHub link or online link where it is available in the chat?
Yeah, maybe. Okay, let me just wait. Maybe I will share with Jyoti sir, and he can share with all the participants. Okay, is it okay?
Yeah, okay, sir. If it reaches to us, then it is okay.
Okay, just a minute. Let me see. Let me see. Just a minute. Yeah, I can see. So I have said in the chat box. Okay, so this is the microblog summarization. So similar framework I have adopted the cross language. You have to just change the objective functions. So instructions are also available on this GitHub. Okay, you can run. And in case of any help, just you can contact on my Gmail ID. Let me type. Okay, so this is my Gmail ID. So any other questions you have?
I think in the chat box, some questions have been put which are unanswered.
I think,
Yeah, I'm seeing.
thank you, Dr. Naveen. How to convert English PDFs, I
Okay.
think.
So yeah. So one question is that how are you generating the embedding of all the language other than English? Okay. So there are many repositories are available on the GitHub. Okay. For the French language, for the any other language. So there are too many type of embeddings are available for the different languages. So maybe I'm using just those embeddings to generate the sentence vector. Okay. So how are you generating the embedding of all the language over other than English? Yeah, it is openly available. Okay. So Gunjan, so it is openly available. Just just search the embedding for the French, embedding for the Hindi language. You can easily find. So another question is that, sir, kindly give me a brief on biomedical image summarization. Okay, biomedical image summarization. So So let me give some information over the biomedical image summarization. Okay, I have already the slide for this question. So how to summarize figures in the biomedical article? Okay, so again, if you want to adopt the same framework, whatever I have explained on the slides, so you have to change the objective functions, right, according to the task. So here, so for example, so what is your target? So you have a scientific article having the figures, and you want to summarize the figures using the text in the article, right? So if you want to get the knowledge about this figure, so again, caption may or may not help. Okay, so that's why you need to summarize this figure. So that is your main task. So what you have to do, you have to design the objective function accordingly. So what will be the input and what will be the output? So input will be the figure captions, okay, of the figure to be summarized, and the sentence is the article, and output will be the subset of the sentences. So okay, so I want to generate the summary in an extractive way. Okay, you can generate the summary in an abstractive way or compressive way or in any other hybrid manner. So the main question is that how to design the objective functions and how to optimize them. So you can represent the solution again in the form of binary space, again with 0 and the 1 form. One means that this first sentence should be in the summary. This one means fourth sentence should be in the summary, and so on. Now coming to the objective functions. So here we can use the different variety of the objective functions. Some of them are anti-redundancy, because the summary should be redundant free. So you have to capture the redundant information in the summary. So you can measure the cosine similarity between the sentences. But before that, you have to represent the sentences into the vector form. You can use the bag of words model, or maybe some BERT embedding, Excel BERT, or many other embeddings are available. And then you can compute the cosine similarity between the sentences of the summary, and that should be very less. So there is another way to measure the redundancy between the sentences of the summary. So maybe you have heard about the textual entailment, which is another concept in the natural language processing. Textual entailment means whether a sentence is entailed by maybe I can explain an example. So definition of textual entailment state that a sentence P called as hypothesis is said to be entailed by sentence Q if P can be inferred from Q and denoted as P, Q entail P. Okay, so here P is inferred from the Q. For example, here text is the if you help the needy, God will reward you. And hypothesis is giving money to a poor man has good consequence. So this is the positive textual entailment. Okay, so here text is entailing the hypothesis. Okay, text entails hypothesis. This is the positive symbol. For the negative textual entailment, if you help the needy, God will reward you, and hypothesis is giving money to a poor man has no consequence. So this is the opposite, something different. So there, here text is contradicting hypothesis. This is the negative textual entailment. And to measure the redundancy, what you can do, the sentences of the summary should not entail to each other. Okay, you can say they should contradict each other. In other words, you can say. So this is the another objective function you can consider. Third objective function you can consider how many sentences of the summary are entailing to the figure caption, because figure caption is at least giving some of the information about the figure. So that's why you can consider that this objective function. the fourth objective function. So in the article, what you have seen, most of the sentences are referring to the figure, like refer to the figure M for. So I have shown the figure 1 for the. I have shown the flowchart of the algorithm in the figure 1. Like you are using the some type of words like figure M or fig M, fig 1, fig 2, fig 3, like this. Okay, so in the summary, what you are doing, you are maximizing this feature. That means the sentences should contain this type of word like figure M. Okay, so M is the figure number. So SOC2 and SOCT, they are the syntactic level feature. So what you can do, you can maximize the number of overlapping words between the sentences of the summary and the figure caption. And the last objective function you can do, sentence to figure caption similarity. That means what is the similarity between the sentence to figure caption. Okay, and you can see this down symbol, upward symbol. So for the good quality of the summary, they should be, so this is the minimization and this is for the maximization. So they for the good quality of the summary, some of the objective function should be maximized, but for some of the objective function should be minimized. So accordingly, you can tackle the you can change the objective function and can adopt in your framework for summarize figures in the biomedical art. Okay, so yeah, okay, fine. Let me see other questions. How to convert English PDF book into Punjab? Okay, okay. So there are some online videos are available. So I have not converted this type of things, but obviously when you using some medium, obviously there will be some error like OCR, okay, or some error will be there. So you have to correct those errors. So I can tell you some. Maybe you can just send me an email on my email ID. I will send you some papers regarding to that, some OCR papers, recent papers. Okay. Any other questions? Okay. So yeah. Okay, I will share my slides with Jyoti sir, and he can share with you. Yeah, any other questions if you have? Okay, so that is the end of the questions and also my slides. Yeah, anything else? Yeah, Jyoti sir. Any other questions? No?
So thank you, Naveen, Dr. Naveen. And so I will just request one thing to Dr. Naveen. We have already, one of my scholar has already sent you the honorarium form, and so you please send me that field honorarium form. There has to be three
Okay.
signatures on the second part of the page, second page, and please also share the slides so that
Okay, I will share. Yeah,
I
I will share
can
with you. Yeah.
just share it with the participants.
Okay,
Thank
I will share
you.
it. Yeah,
Thank you so much. So we will end this session here and we'll start the next session at 6:15 by Dr. Asif. Okay. So thank you, Naveen. Bye bye and see you
bye.
again.
Bye everyone. Yeah, thank you.
To all participants, request, I think we have already shared your quiz marks. I think it should be visible to you now. And today is the last quiz, as well as we have also shared a feedback form in the morning. So please give your feedback about regarding this session. Whatever you feel, good, bad, but your feedback will matter so that in future, again, if we are going to say offer this sort of course, we can surely take care of that. We can improve on that. So please share your feedback.
Excuse me, sir. Sir, please share your feedback form in the Google chat box.
In this chat box, again, I am copying here.
Hello, sir. Where are the marks shared
I
here?
think in the morning we have opened the marks. That means your marks should be visible to you. You can,
No, I mean in the where it is.
in
Means
that
where?
same Google link, whether Dr. Bhaskar is there. Bhaskar,
Okay, okay, okay. Means in that Google link only that response should be seen.
I hope Dr. Bhaskar has done. I'm just let me
Okay.
connect with him. He
O-
told me that he has already made that available. That means he has opened that option that you can view your marks. So please check once, everyone, please check it and also check this feedback form. It's opening or not. So please check your mail ID. I have released the marks. Morning it was some problem with Bhaskar sir. He was not allowed to send email because he had already crossed a limit. So please check now. I have just released whether it's visible to you or not. And there is no link which I can share. It will be individually sent to your email ID. Can anyone confirm? Hello, am I audible?
Hello. Sir, not visible.
Hello. Sir,
No,
I'm
check
not
your
marks.
email ID. Check your email ID.
Yes, sir, check
No,
the
sir, it is
email.
not
I
reflected,
just
sir.
did.
Not there.
And there is no link or no mail, sir, like that.
A mail will be reaching to you basically with the marks because
I received, sir, mail.
you have you received? Okay.
Yes, sir.
So
Yes.
please wait. Others, please wait, because if some one person has received, then that means the mail is going on.
Okay.
Might be in some cases, no, it takes some delays for depending on the settings, firewall setting, etc. There can be some delay. So please wait. Again, I will after some time again I will release this one. Once again I will do this. Which two?
Hello. Hello.
Yes.
Kshitiz from IIT Patna. So basically, we had a link and we got this link and we were asked to present the Sevak demo. We were asked to present the Sevak demo, our project. So,
Okay. On behalf of Asif, basically you will be presenting. So can you just confirm your name?
Yeah, I'm Shitin Mishra, and with me there are two persons.
Just a minute.
Ratnesh and Azan.
Just tell me your name. Okay. KSHITIJ. TI. But I cannot find in participant list. I am not finding your name.
Shitin Mishra and Ratnesh Joshi.
KSHITIJ. Okay. Okay, I have got. So change role. Already you are as a presenter. So you can share your screen.
Yes. Okay. And there are two more persons, Ratnesh Joshi.
Okay, can you just paste their names?
Yeah, I'm writing the name itself.
In the chat window itself, you write the name so that I can give them the permission.
Yes, sir.
So Ratnesh Joshi. One more.
Okay, so other person is Azan Zafar, but he would be presenting from my laptop itself.
Okay, so two are sufficient, no?
Yeah.
Okay, so I have given you the presenter's privileges.
Okay. So should I start now?
Just wait for some more minute. I think the session is supposed to be start at 6:15.
Okay.
So we'll start at 6:15 because this is a break time.
Okay.
So this is page 2. Responses, image score. So can anyone else can anyone else confirm that they are receiving any mail?
Yes, so the mails are being received.
So you are able to see your grades? Because I am not getting those mails.
Excuse me, sir. Actually, you are not receiving quiz 1 and 2nd. I am receiving quiz 3rd mail.
No, quiz 3rd is not yet happened. So
Yeah. But mail is provided by your side. But quiz 1 and 2 marks I cannot see.
No, I have just released the scores for quiz 1 and quiz 2. So
Yeah,
that's why
that
that's what I want to get.
that mail I can't
Okay,
receive.
then let me just see check it once.
Okay, sir.
Okay. Otherwise, there are other options. We do not want to disclose the marks to others. So that's
Okay,
why that
sir.
is the best option, so that individually you will get your own marks. Last
Okay.
option is obviously to display it as a page so that others can also see your marks. That we can anytime do, but that I'm not basically trying to do that. Give me some time.
Oh, okay, sir. I will wait.
Hello.
Yes, Kshitij.
Yes, sir. Should we start, sir, now?
Yes, yes. So to all the participants, Dr. Asif is also here.
Yes, yes, yes. Hi. Yes, yes.
So
I can hear you. Good evening.
yes, yes,
Good
yes.
evening.
Good evening. I can hear you.
Okay.
So to all the participants, a very good evening, and to all the experts and presenters, Kshitij and Ratnesh also. Good evening. So, Dr. Asif, let's start this session.
Yes, yes, sure. Okay. So, good evening to all. So, mainly we'll show you one of the project that last time in my presentation I talked about this building the chatbot in Indian languages. So, we'll Kiti's, Aizan, and Ratnesh are the students, PhD students. They are working on this particular project. And we'll show you that there are three domains we are developing chatbots. One is railway domain, then the judiciary domain, and the healthcare domain. And for the railway domain, already we have developed it. And we'll show you the different steps that are followed for developing the chatbot. But at first, we'll give you an overview, and then we'll walk through the demo, and then gradually we'll show you that how to build this model. Second part will be taken by Jisan, who is another PhD student. He will show you that how the deep neural network based model, particularly the encoder decoder model, will be used for generating the responses. Now, response generation means is basically if you ask a kind of questions and then system will generate a response, which is a kind of in a multi-turn setting, which is dialogue. So with that, I think now we can start. So who will begin? So Kshitij, are you beginning? Huh?
Yes, sir.
So please share your screen and then maybe we can continue. Okay.
Okay. Is my screen visible?
Yes, I can see. Go to the full screen. Yes.
Yeah. Okay. So I'm Kshitij Mishra. I'm working with two PhD scholars, Ratnesh Joshi and Azan Zafar, in a project named Sevak. Basically, this project aims to build an intelligent Indian language chatbot. Here there are three presenters. We all three will present. Ratnesh and Azan will follow with myself, and we are from Computer Science Engineering Department at IIT Patna. So basically, they are the primary investigators in this project from IIT Patna, as Dr. Asif Iqbal, and from IIT Bombay, Professor Pushpak sir, and IIIT Hyderabad from IIIT Dr. Manish Srivastava sir, from Jadavpur University, Dr. Dipankar Das sir, and from Wipro Technology, Arindam Chatterjee. So basically, the objectives for the main objectives to develop this chatbot were that we want to develop a chatbot, open source chatbot, which would be pluggable engine and which can understand written and spoken Indian languages, basically Hindi, Bengali, Tamil, or Telugu, along with the English itself. And it should be able to handle multimodal data also, like text or speech. And as it is happened that common persons used to talk in code mixed language like English, so it should also be able to handle those type of languages. So basically, our aim is to develop that chatbot in three domains: railways, primary healthcare, and judiciary. We focused on four languages, primarily English, Hindi, Bengali, and Telugu. And we also code mixed for all these languages, like English plus Hindi, Bengali plus English, and Telugu plus English. So, who are the beneficiaries? Main beneficiary would be the common man who would be seeking railway, healthcare, or judiciary related information. And there could be another beneficiary also, like Ministry of Health and Family Welfare or Ministry of Railways and Department of Law and Justice. We can provide the chatbot which can work on different tasks. So, okay. So the main goal of our chatbot is to have a domain specific, have a chatbot which can understand domain specific context and vocabulary, which can converse with a layman or common person, which can comprehend the social media language and lingo of a common person. And this is like code mix, and which can cover all modes of communication, because what happens that user used to communicate from different modes of communication like Facebook or WhatsApp. So the chatbot should be available on all other common mode of communications. It should be easily accessible and usable. So these are the main goals of our system: domain specific, context understanding, multimodality, code mixing, and the mode of a universal communication, so that it could be communicated from easily from anywhere. The impact historically in from 2019, in there had been several analyses done, and for chatbot impacts, like Business Insider says that from until 2024 there will be the market size of $9.4 billion from $2.6 billion in terms of CAGR rate. Similarly, Global Trend Analysis reported that by 2022, banks can automate up to 90% of their customer interactions only using chatbots. Outgrow also said that 80% of business are expected to have some sort of automated chatbots. And similarly, VentureBeat said that 300,000 chatbots would be on. There are 300 chatbots on Facebook, and 50% of customers expect a business to be open, like 24/7. And lastly, this is a just important factor, that chatbots can save up to 30% of the in-customer support cost. So this works as a very main factor in e-commerce domain. And in Indian scenario, what is happening in banking sector, like State Bank of India, HDFC, ICICI, all banks they already have their chatbots. Similarly, insurance firms like Bajaj Allianz, Birla Sun Life, they also have their chatbots. E-commerce companies like Lenskart, and we already see that some type of other e-commerce companies, these companies, they have the chatbots. Travel companies like Yatra, Make My Trip, all these have some type of chatbots. Basically, our domain is railway, railway and judiciary and healthcare. So, in judiciary and healthcare, there is nearly no chatbot in India, and in railways domain also there is a one chatbot, DISA, but it mainly answers basic frequently asked questions like what is 2AC, what is Tatkal. It basically uses query matching architecture, and it does not have any machine learning architecture. So, what is the key role? Our key role of India in chatbot market today is that there is a large mobile-enabled, message-friendly customer base. So, if there is a chatbot which can provide help even to the person itself, then that would be the better. But the challenges are, there is a challenge, and the challenge is that none of the available chatbots supports Indian languages, and to incorporate Indian languages offers a great challenge to us. So now I'll transfer to Ratnesh Joshi from this module itself. Ratnesh.
Hello everyone, Ratnesh Joshi here from IIT Patna team. So we will be going over the proposed solution for this chatbot problem, multilingual chatbot problem that we are facing. So for building this chatbot, we follow the modular chatbot architecture, which splits the conversational process between the human and the bot into different modules. So as you can see, the user gives a query, and this query is passed into the NLU module, which is short for the Natural Language Understanding module, where we try to understand the actual purpose of the user utterance and any important information that is present in that user utterance. For example, for the query give trains from New Delhi, the intent that we are focusing on this particular utterance is that we are trying to find trains, and then the important information that we can get from this query is the station name or the location name New Delhi, right? And these two information, that is the task and the uh, slot that we are calling as source here as New Delhi, is passed into the dialog management section. The dialog management section basically holds some policies which govern the flow of the decision making process by the chatbot. So for example, some examples of policies can be, if the bot is not able to understand the user query clearly, it should ask the user to clearly explain the query again. Something like, please, can you rephrase your query? Or it could be some query like some policy like, if the user utterance matches exactly to some utterance present in the training data, instead of making some complex calculations, we should just reply with the phrase that is already available in the training data. During this process of policies, the bot also connects with the database. So for example, in this query, let's say if the query was something like search trains from Patna to Delhi, after we have extracted that the source is Patna and the destination is New Delhi, we will then go into a database where we will fetch all the trains that satisfy this condition and then extract those train numbers or train details, and then these details will finally be presented to the user. These details are presented during the phase called the natural language generation, where all the information that has been extracted from the database is finally presented to the user in a user understandable format. So here is some basic idea of the three processes that I just mentioned. So NLU, as I said, it takes the raw user utterance and converts into semantics form of dialogue acts. So intents, slots, intent, which are referring to the intention of the task, intention of the utterance, that is what task to perform, and slots referring to the important informations like source, that would refer to a location, destination, that will also refer to a location, a date, maybe PNR number, a mobile number, or any useful information that can be present in the user address. Dialog management, as I mentioned, it is basically a set of policies that uses the information extracted during the previous phase to formalize the action that needs to be performed by the chatbot. And that action is finally formalized into user understandable text using the process natural language generation and finally presented to the user. This is the basic process of our chatbot conversational system, where, as you can start from the left side, we basically extract domain specific data. So for example, train names, train details, station details. Generally, user asks queries from Twitter, from Quora, or asked from railway information centers at the railway stations, and all these domain data is extracted, and then we prepare a model using this domain data. In the second part of the offline process, we formalize the actual model, where we break down the process into intent identification and entity identification. As I said before, intent refers to the purpose of the utterance and entity refers to the relevant information in the utterance. Both of these processes are merged using a intent classification model and a named entity recognition. Both of these processes are basically running on a particular system and can be thought of as an online process. Now, since the model needs to be served to a user, it needs to be available over multiple platforms. So we put the particular model by using an API or any other process on these variety of platforms. For our Civic model, we primarily focused on WhatsApp, Facebook, our own web-based interface and an ASR-based interface. Another important module that we have for our chatbot is a spell checker module. Sometimes people make mistakes, especially in the name of like say station names, but these are important information that needs to be corrected before the model can perform its decision. That is, the chatbot can actually reply with correct response. So therefore, spell checker is quite important for the chatbot architecture. Similarly, the NAI process and intent recognition process borrowed from the offline process is transferred and then connected to our database, and then we extract information, and then this extracted information is finally through the NLG process converted into user understandable text and finally given to the user. Okay, functionality of our chatbot. So domain adaptation. So we are trying to build a chatbot where the basic processes remain constant, and just by changing the data and basic storyline, we can adapt our chatbot to any particular domain. State of the art. So we are using deep learning based architecture. Context understanding uses latest word representation techniques. So for our model, we are using glove based embeddings. Keeps track of conversational context. So currently we are using something that is referred to as dialogue state tracking, which maintains a history in a form of dictionary. So all the slot values or important information mentioned in the previous statements are maintained throughout the conversation. Spell check and correction. So as I mentioned, if you mispronounce or miswrite the words, it can be really difficult. For example, you're searching train from Patna to Delhi, but you instead write Patna to Dela. So now you require to change that Dela to Delhi so that the actual response that you wanted can be actually generated. Language support, as I said, though English is widely used, but we require the language to be available to more people, as English is only spoken by around 22% of the population, right? So therefore, we are trying to provide a chatbot in local languages, Hindi, Bengali, and Telugu, being the primary one that we are focusing right now. Modularities. So modularity refers to the front end that we are using to present our chatbot to multiple people and making it readily available. So the ones that we are using are Facebook Messenger, WhatsApp. We have a web-based API that is running on our server. And finally, we are using social media languages. That is the language that is used by most of the people when talking on social media. That is code mixed languages. So sentences like Patna se Delhi ki trains dikhao, ya fir search train from Patna to Delhi is the original sentence, but now it's get converted into a code mixed format where even though we are writing in the Roman script, but the actual words are coming from the Hindi language. Similarly, the code mix versions are available for Benglish and Tanglish, depending on the status of your first and second languages. The language often mixed when conversing generally. So that was the end for the proposed model. Now we'll be focusing on the data creation and collection procedure. Over to Ezan.
Hello everyone, I am Ezan Zafar. I will walk you through the module second module, that is data creation. So first of all, I would like to say you about the challenges that we face in the data collection. As we all know that we will work in the deep learning models. So deep learning models require a large amount of data. to train the model. So as Ratnesh has already told you that our main modules for the chatbots are NLU, that is natural language understanding, and dialogue management and natural language generation. These all are the deep learning methods which require a significant large amount of data. So we have collected this data from the various sources like crawl the data from different websites, from tutors also. But the main problem that we face that after collecting the data, we have to check whether this data is appropriate or not. And after checking that we have an appropriate data, the next phase is to ensure that the proper format of the data. Like for the NLU tasks, we have two different tasks. That is intent detection and slot filling. So for the both of the tasks, we have to properly annotate the data according to that task. So collecting of data, then proper format of data, and then annotating of data is required after we collected the whole data. But for the collection of data, we cannot use the Quora, because some website like Quora and other website, they do not allow the data crawling from their website. And most of the sites, we get the data in English format. So, and most of the site will give the data in the English format, not in the other Indian language such as Hindi, Bangla, Telugu, and the Kotus also. And also we have crawled some data from Twitter also, but the problem with the Twitter crawl data are that the replies in the Twitter tweets were not authentic. They were not given by some official accounts of Indian Railway or Indian railway ministers. They were given by some persons, but we have collected that also. So in the data collection parts, we have collected the data from the different sites and through the manual interventions where crawling is not allowed. For this, we have used the Indian Railways.info and bookrailticket.com. So mainly we have crawled the frequent asked question from this website, and around 85 questions we have crawled, and we have divided this question into two parts. The 20 questions were comes under the part of basic train information queries, and the 65 questions were come under the part of detailed question answer. So whole data that we have crawled are related to the PNR query, booking status, as class code, quota codes, coach code, Tatkal booking refund. These types of frequently asked questions were there in the railway and the book ticket websites. So how we have divided this here? So as you can see that PNR query and the railway status code, class code, this will come under the train information query, because they all are related to the trains and they are straightforward answer were there. But in the detail where the step-by-step process are required for the query, like refund rules. Someone say what is the rule for Tatkal ticket refunding? Can I get my refund? So they required a step-by-step process. So we have created so we have put it into a detailed question answer format. So this is a sample for the first one where the basic train related FAQs are there. So question can we get the PNR? How can I find the PNR? So the straightforward answer will be given. And similarly, the second phase will be where the detailed answer will be given that. And as you can see that in this, the answer were also very long. Like the question that as I have already told, that question will be like how my confirmed ticket will transfer to somebody else, how I can get the refund from my Tatkal cancellation. This type of question require a detailed answer. So this will come into the second frequently asked question types. And after that, we have also created a generic templates to create some conversations pair, because this type of question answer is like a QA pairs, one question, one answer. We cannot say that these are in the conversation format. Till now, this also the frequent asked one is directly question and directly answers were given. and it's in same the frequent asked question part 2, the question will be there and answer will be there. They are not in a conversation pair. So to make a conversation pair, we have created some generic templates. And also we have collected data from the tutor. For the tutor, we have used the Tupi, which is a Python-based API for real-time tutor extraction. So from the tutor, we have collected around 17,557 data. And the tag which we have focused are Indian Railways, Rail Seva and Railway Seva IRCTC. Firstly, we have also used the Piyush Goyal, Railmin India also this tag. But with this tag, we were getting in a lot of domain irrelevant data. So later on, we have dropped this tags and only use those Indian Railway Rail Seva tags. And as we all know that while using the QP package, we get a lot of information from the tutors. So, but we have focused only on the name, a screen name, and reply to a screen name. And what is the tut? We have focused only that these four or main points. And from that from the API result that we got from the QP. Why we have used the name and the reply screen name? Because from name and the reply to a screen, we can create a conversation that the screen name this has tweeted this and somebody has also replied to this screen name. So we can create a conversation from this, how a real life, how a real-time conversation looks like. So this is one example of data collection from tutors. As you can see that there's a name the tutor username and the real tutor username and the screen name that they have used for the creating to display on the screen. And similarly for the reply to screen name is also for the different users who are going to reply on that. So yeah, after this after this till now we have created the frequent asked questions and the Twitter data, but this data is definitely not exhaustive. So we need something more for to search for the trends.
Can you go to the, let's say, okay, continue this.
Okay, sir. So this data is still not enough to create some database. So we need some database queries where we can look for the train number, train station name, what are the trains between two stations. So for this we have created one lookup table, and that we have used as a database. To create this lookup table, we have crawled the data from the creative.com, and to do this, we have used the request package in Python, and we have crawled around 3,752 train details. And in the train details, we have mainly focused on the train number, train name, and the station code, arrival, departure, and the distance. So that data look like this. As you can see that there is a train name and the station that it's covered from starting to end, all the station, respectively their station codes and their arrival time and departure time and distance. So we have used this data to create our database, and the queries that can be answered from this data, like a train between two stations, arrival time of the train at particular station, what is the departure time, what is the total distance train that can cover between two stations. This type of queries are answered. And similarly, as this data is available in English language, so we have translated this data into a Hindi language and the other sources also in Bengali and Telugu, so that we can use this as a Bengali and Hindi database to connect our bot with their respective bot with the respective database. So using this, we have created using this data lookup table, Twitter conversations, and the frequently asked data. We have created this number of around 9,186 dialogues, and that 9,000 dialogues comprises of around 1,19,000 utterances. Each utterances, and the minimum and the maximum number of utterances per dialogue is 8 and 18. Means in a conversation, the minimum utterances is 8 and the maximum utterances we have 18 user bot utterances. So how we have created this message? So firstly, we have designed the templates, and using that design templates, we have manually created some data. After manually creating the data, we have paraphrased the conversation data into a different languages and then converted back it into a English, like from English to German, German to Chinese, Chinese to English. And then after converting, we cross check that data that we have converted, whether it is semantically correct or not. And the third way that using these two, we have created our prototype bot, and we have asked our lab member to test our bot so that we can get an engaging user into a conversation. And after all this, we have annotated our crawled conversation into a needed format. Like for intent, we have defined out the intent. For the slots, we have defined what are the slots available in this way. So basically, right now, till now, our bots were focusing on only 3 domains, like trend-related queries, food-related queries, and the complaints. So this is a design template that we use in a one of the design templates. Like first, when the user will come to the bots, he or she will start the conversation by greeting, like hello, hi, this. And similarly, the bot will also greet the user, hello, I am Sevak, how I can help you. So then the user will provide a query for the train search. Like the query will be like, I would like to search a train from Patna to Delhi, or if there is a query about the complaint, then it will search, I have a complaint regarding the train toilet, I have a complaint regarding the train, like this, any query. After the user query, the bot will respond. After the user query, the bot will detect what is the intent of the query, and according to that, bot will perform the task. And in the end, bot will ask if you have other queries. If the user will reply yes, then the bot will again repeat this whole step. Otherwise, bot will say goodbye and exit. So this is a one sample conversation that we have created using the different person. Like our team lab member have use our bot for the conversations. So this is the one result that bot has faced. So additional to these 3 tasks, we have also added some additional tasks like train schedule, coach layout, train live station, train information, train fare, coach ability, coach layout, and train reschedule information. This 8 information. Firstly, we have for this also we have created the design templates for each. What are the design templates? How the conversation flow will happen in this type of. If someone want to know about the train schedule, then he should give either the train name or the train number to get the schedule. So in this way, we have designed the templates and we have created the dialogues. For this, we have manually created the dialogues for each, manually and semi-manually for the single task. And similarly for the multitask. For the multitask, we have combined the different tasks. Like first, the user will do the train search query. After the train search query, he will get all the list of, suppose he want to know the train between Patna and Delhi, and the total number of trains bot is showing 5 trains bot have shown. So from the 5 trains, he want to know the fare of some train. So he can ask that what is the fare of this train of third AC. Similarly, after knowing the fare, he can get to know whether the third AC is available or not, whether seat is available or not. In this way, we can say that it is a multiple task. That's one task followed by another task. So in this way, we also created multiple tasks data. So for the single task data, the average utterances per dialogue is 6. And but for the multitask conversations, we have the average number of utterances per dialogue is 60. So this is the one of the example of the multiple tasks data. First the user have asked about the train fare, and then the user has asked about the coach layout information, and then again he has asked about the train fare of the different end. So in this you can see that intent annotation also and the slot filling also. As you can see that in the line number 3, 19019 में उपलब्ध coaches दिखलाई, user have asked about the coach layout. So 19019 is a train number. So similarly, we have annotated this slot also, that 19019 is a slot which is named as a train number, and others are 000, which means that they are others are not the slot, only the first word is a slot. Similarly, for the train fare also, we have created different slots. For like as you can see that what is the price of 2AC. So that 2A is a class code slot, and the intent for this is a train fare. In this way, we have created our conversational data for multitask. So this is the statistics of the data that we have created so far. And after creating the data, we have translated this data into a different languages using the Google translation, and then after that, each person from each institute, like from Jadavpur Institute, they have verified whether that data which we have translated from English to Bangla is correctly translated or not. If not, then by manually intervention, they have corrected that. Similarly, IIIT Hyderabad has also converted the English data into a Telugu version. And after that, we have to use the ASR. For ASR also, we have 4 languages. So we have recorded all the statistics as 1500 conversation is been recorded in English, and 2500 conversations were recorded in Hindi and Bangalore and Telugu also similarly. So for the tasks are triggered using the queries like search for the train between Delhi to Mumbai, what is the fare? Such queries were created for each of the 10 chatbot, and 10 chatbot means English, Hindi, Bangalore and Telugu. Similarly, the Roman version of Hindi, Roman version of Bangla, and Roman version of, and again the code mix version of English Hindi, code mix version of Bangla English, and code mix version of Telugu and English. So this is the task related queries, that conversation data statistics for the task related queries. Now we have come to that.
No, I think this one is okay. Now directly go to the maybe how the story is created and all these demos. Okay, so judiciary, maybe this one domain is okay, railway domain. Okay, now let's go to the actual implementation.
Okay,
starting from the demo. Aijan. That
Sir,
will be good, I think.
Sir, first we have planned to first give the introduction about the implementation, how we have done the implementation.
That is so. That is so. That is so.
After that, we will give the demo.
So that is okay, but show the implementation, how the story is created, all these things. Okay, so I think the judiciary and healthcare, you can, for the time being, can skip. Okay.
Okay.
Those details is not needed to be covered. So skipping this, you go to the next slides.
This will show how the implementation and the demo part.
So now data is part over, or what you have now, Aijan? How many slides you have?
Sir, we have around 61 slides total. After that,
no, this you leave for the time being. Okay, methodology, maybe the actual implementation in terms of methodology, that probably is okay. So module 3 is okay now.
Okay. So
module 3 is okay. Module 3 will talk.
Okay, sir. I'm going to present the module.
Briefly you talk about, because mainly the demo. Okay, we have to show demo and then implementations. Okay, how the things are implemented.
Yes, sir.
They got a fair idea.
Okay. Well, so what is the methodology sensor? So as already Ratnesh has stated that our chatbot architecture consists of 3 modules: natural language understanding, which takes a user's raw utterance as input and converts it to the semantic form of dialogue apps. Dialogue manager responsible for keeping track of current dialogue.
ना ठीक है इतना इतना भी तो मतलब थोड़ा तो भी करके बोलो बहुत फास्ट जा रहा है
Okay,
so
okay.
this I think he has already explained no this
Yeah,
part
yes,
already
yes.
Ratnesh has explained so maybe you come to what Ratnesh has not explained huh? So go through it okay now we can explain from this
Okay, so
right.
so chatbot modules. So first step, this is the first step of most of the dialogue systems. What it does, it does a dialogue act classification, intent detection, and slot filling. It plays an important role in deciphering the syntax and semantics of user input to aptly produce WhatsApp reply. The intent classification focuses on semantic meaning of the input. Slot filling focuses on the extracting the relevant information like name entity. So how the intent annotation is done? We check the predefined task available in the railway domain such as train.
ये थोड़ा धीरे-धीरे बोलो थोड़ा स्लो बोलो हाँ इतना फास्ट जाने से लोगों को पता नहीं चलेगा ना ठीक है because these are the important things
okay so how the intent annotation is done? First we check the predefined task available in the railway domain such as train search between stations, train fare, train information, food order, complaint register. So these tasks will work as user's instant for his or her query. We try to understand the flow of each of the tasks, such as for train search between stations. User is requested to provide source and destination stations. Only then a railway API is able to give the available trains. So this is the flow that the API is asking for source station, destination station. So these can act as entities which API is asking. So when bot will ask, bot should ask for source station, destination station, and these will work as a slot. In this way, we try to understand the flow of each of the tasks and try to convert each of the tasks for our bot. We annotated different user utterances, having or not having these requested information with appropriate intents. By having or not having, we mean like suppose a user comes and says that okay, please search the trains. I need to search the train, he says. So this intent is also for train search. And another user comes and he says search the trains from Patna. So he is giving the information of source only. So that should also come in the intent of train search. Then third user comes and he says that search the trains from Patna to Delhi. He is giving all the informations, the source station, destination station, in the one utterance itself. So all these utterances should be classified into the one intent, that is train search. So all these type of intents were annotated for one task itself. And by slots, what we mean, the requested information such as source station or destination station from user will act as slots. And these are extracted in the form of entities by natural language understanding module from a user's utterance. So intent classification, this is done to highlight the purpose of the user, as Ratnesh has stated already, purpose of the user utterance. It helps us figure out the task to invoke, like search trains from Patna to Delhi. The intent should be train search. And then suppose the user is saying what is fare of 12397. So 12397 he is giving the train number. The intent should be train fare. So bot should be able to discriminate between these two intents. So how he will be able to discriminate? By classifying the intent. First utterance will be classified as train search. Second intent would be classified as train fare. Similarly, the bathrooms in the trains are dirty. So here there is no information, nothing, but the intent is like that. It is suggesting some complaint. So bot should be able to know that it is something related to complaint and classify it into complaint. So to bot know, we really need machine learning model and large amount of really need to train the machine learning models with a large amount of data. So second is so this is intent classification. After intent classification, what a module do, that is slot filling. So this is the process of highlighting tokens relevant to the conversations, like this search trains from Patna to Delhi. So what are the relevant tokens for this intent? Source station and destination station. So this is what is done in slot filling. these tokens are relevant when extracting data from the database. This also helps us figure out if we can directly continue with the task or we need more information. So how it is this done? Like user came and as I had already, you will say I want to search trains. So bot will know that okay, he did not get the two slots, source station and destination station. He will ask for can you give me the source and destination station, and user still gives only the source station. And so bot should able to figure out that this is only the source station and still I need the destination station. So bot will again ask that okay, can you give me the destination station also. In this way he will be able to continue. So in railway domain, how many intents? Basically, we are here we have 19 discrete intents. Some are general intents like greet, hello, or hey. This would be in this can be in all conversations. Goodbye, like bye, goodbye. Affirm, usually is affirming something like what is asking that okay. Can you give me? Have you provided all the information to me? So user is affirming yes, I have provided. Deny, he may deny something like okay, he do not want to give or he had already give information. Inform is like whenever any slot information is given by the user, that will go into the intent of inform. Then from inform intent, other entities will be get extracted. So like my PNR is 123567890 Delhi. So the information is 123567890. That is the PNR number. Okay, so then the other intents are like train search, complaint, food, botchel, live train status, train fare, train info, train. These all are task intent. Okay, the task we are focusing on. Train search, user want to search trains between two stations. Complaint, he want to complaint. He has a complaint which he want to register food. He want to order some food. Train fare is related to the query for fare of some train or in some coach. Train for asking the information about a train schedule. You want to know the schedule of a train, some train coach layout. What is the coach layout of train 1 to 3? So it's similarly, all these intents are there. Okay, so now the core component comes the dialogue management for any chatbot. So this is the central component of any chatbot, which takes the input, that input which has been extracted information, which is the extracted information from the NLU component itself. This is a function that controls the next action during the conversation. So what we mean by controls the next action? Whatever has happened in the dialogue, it keeps track of those things, and then on the basis of those things, it tries to predict the next action. So based on the intents and entities extracted by NLU as well as other context like the conversation history, DM decides which text response should be sent back to the user or whether to execute some custom code like querying a database. By querying a database, we mean like, okay, he goes to a database when he has already received all the information he was requesting, like train search between stations. Then now he have to go and query a database. Then he will extract all the trains from between like Patna to Delhi, and he will give those trains as a response to the user. So dialog flow, how the dialog flow has been created. So basically, we are just giving a sample for food related query. The intent has been detected that okay, it is related to food related query. Now bot will ask the PNR number for train information so that he can know okay in which train the user is traveling. So he will ask the PNR number. Then he will give the choices to user that he can book the meal from net itself, like there are already catering sites. From there he can book, or he can book the food from pantry car, or in the end, if still he do not want to go for any of this, he can go for station. You can go to the cars that available at stations. So if he goes for pantry car, then what will happen? He will further ask that what is your coach number and seat number. He will ask that okay, what are the specifics of veg and non-veg. He will ask for number of people, how many number of people they were ordering for, and then save the whole request and send it to the pantry car service. Yes, and register the request and tell them that okay, your order has been placed and it will come in some time frame. Then after that, he may go for another query. So this is the dialog flow, an example of dialog flow for food related query. So this is basically based on the request asked by APIs. How we have created. We use these queries as reference to create the dialog flow. Like as I said that what if not found some slot information, what will request relate to that slot information related to that task. User will inform that request slots, and once all slots information for a task is obtained, what will respond with the final answer. Okay, so one example of dialog flow. This is first user comes and he greets. What also greets is, then he asks for train fare. What activate the train fare form. So then whatever in this train form, whatever slots he need, he requests continuous all those slots to the user, and when all those slots are received, he will in the last tell the needed response. Like hi Sevak, how can I help you, sir or ma'am? What ask? Can you tell me how much it will cost from Delhi to Howrah for 2 AC? What says please provide us your train number. User said tell the train number 12274, and what gives the answer that fare of 2 AC is 2892. Okay, so last module is NLG module. It forms the information generated by the DM module into human readable text. And for current chatbot, we are using template based energy. So how it is how the template based energy is generating the response. So from DM, what we get from DM, we get that okay, the cost it is already tracking that okay, for which the information is asked. So the cost type is 2AC. The pair which DM has already tracked that okay, the pair is 2892 for 2AC. So these two informations will come from DM. Then that we already have predefined templates, the pair of, then there is question mark, means here the course type will come, then is, then again question mark, here the pair will come. So the NLG output will be, it will place the course type and the course type and pair in their respective places. So the NLG output is the pair of 2AC is 2892. Okay, so now module 4 implementation, and this will be taken by Ratnesh himself. Okay, Ratnesh is going to share, so I'm going to share my screen.
So if you okay, Ratnesh, but any question? Maybe anyone? Can you check the chat? Okay.
Okay. Your mic.
Hello.
I can hear you.
Okay. Thank you. So we'll start with the module 4, which is the implementation part. For the implementation of a chatbot, we use the framework called Rasa for the implementation and deployment of a chatbot. So why did you use a particular framework instead of building everything from scratch? Obviously, the chatbot process includes many modules such as NLU, dialog management, NLG, but it also includes other important parts such as the front end, the database, etc. So when you are building a chatbot, you not only require the functioning knowledge of all these particular modules, but also the knowledge of how to connect all these modules together. This can be quite a hectic process, and because of this, it takes our time from focusing on the actual things that we are trying to work on. So because of these things, we decided to use a particular bot framework, Rasa being the one that we chose because it is open source and open licensed. So what is RASA? RASA is an open source machine learning framework for building contextual AI assistants and chatbot fulfilling two tasks, that is understanding the user messages and giving the actual responses, giving actual coherent responses to the user queries. Okay, so the natural language understanding part that we have explained quite a few times during our presentation. We'll go over how it is performed in the RASA chatbot architecture or framework. So first of all, the intent detection and the slot filling, these two processes are broken down and handled by separate classifiers. So in the machine learning pipeline, we use an support vector machine based intent classifier to find out the intent behind the user utterance, and we use CRF, that is conditional random field based entity extractor, to extract all the important information like location, date, etc. In RASA, we also have a newer version which is called the dual intent entity transformer, where basically we merge the intent classification and the entity extraction process into a single transformer model which take care of both the tasks. So this is the format in which our data is stored in RASA. So for example, the original utterance was something like, what is the train available from Delhi to Patna? Now, since Delhi and Patna are information that is required to find out the trains, so we annotate the data with the particular entities marked with their slot names as source and destination. And this particular example would be somewhere in our intent file marked with the intent train search. So that is the actual task that we are trying to perform with this user query. An example of a story which basically formalize the conversational flow during the dialog process. So the dialog would start with the user entering something like greet, so like hello, and the bot will reply with a greeting of its own. So all the utterances with star are the user utterances, and all the utterances with dash are the processing performed by the bot. So user says a query, something like, I want to check whether a particular coach is available in a particular train. So the bot starts to process and figures out that in order to perform whether a particular coach is available in a particular train, we require what the coach number that we are supposed to check and the train numbers we are supposed to check. So it goes over, figures out that the class code or the class that we are supposed to check is missing. So it asks the user that we require the class code. So the user enters the class code. Then the bot figures out that the train number is still missing. It asks for the train number, and finally, when the train number and the class code are present, the bot gives it result. Now, instead of saying the query something like is a particular train, sorry, is a particular class available in a particular train, the user said is 2AC available in 12302. So in that case, all these unbolded parts would be missed, and directly after the form where the particular task was triggered, the bot would directly give the results and ask the user if it has anything other it want to ask. Now the dialog management. How dialog management is performed in RASA, where basically we have something called policies, something called a domain file, and something called an action. Dialog policies, as mentioned before, are basically rules which govern how a particular utterance of the user will be handled. Some example of policies could be memoization policy, where if the particular user utterance occurs exactly as it is in the training data, we directly respond to the user with the response already stored in the training data, and there is no much need for further processing. We can also have fallback policies where if The intent classification process is stuck between multiple intents, so we cannot say whether a particular utterance belongs to a particular intent with high confidence. Then the bot should ask the user to rephrase its utterance. That is called the fallback policy. Similarly, form policy, as we mentioned in the previous example of story, in order to perform the task of whether a particular class is available in a train, we need the slots, class code, and the train number. So the form policy is focused on this process where it manages the slots required to perform a particular task efficiently. So for example, the task of train search requires the source and the destination. The task of train fare would require the source and the destination and the train number and also the seat number or class code, right? So all of these, so basically you are trying to fill a form from your slot values, and when all the slot values are available, we can finally go and execute the task. The second important thing that we focus in dialogue management part is actions. Actions are basically Python codes that formalize what we have to do after a particular number of slots have been achieved. So how to actually perform the task, that is going over and calling an API or going over and extracting data information from the database. All of these are done using a Python code running stored in an action file. Domain is basically a file that holds all the names of the intents, slots, actions defined in our model. So basically it's a screenshot of our model. So instead of going over and finding out whether a particular intent is available in the intent file, whether a particular slot is available in the slot file, so we can just go over the domain file and see whether a particular instance is already available in a bot or not. So it is like a screenshot of a model. Similarly, in the dialogue management process, we have something called a tracker. A tracker keeps the information during a conversation so that we hold the important information spoken in a previous utterance during our current utterance. So for example, the previous utterance was search train from Patna, and then as we mentioned before, the search train process requires not only the source but only the destination. So the bot should ask, where do you want to go? The user replies with New Delhi. Now, if we only look at the current utterance, the utterance only has the destination. But because the tracker is maintaining the entire conversation process, so it knows that in the previous utterance, the intent was already fixed to train search, and we also have the information of source from the previous utterance. So we can go ahead and perform the task of the train search, and then you can go in the database and figure out the response, converted into natural language and present it to the user. So this is how message handling is performed in Rust. So this is a basic example of Rasa running on console. So the bot said hello. The user said hello. The bot replied with a generic response. The user entered search train from NDLS to PNB. The bot gave all the trains available, and then the conversation. So this is again an example of a story, how a story is formulated. So for example, your conversation was, hello, how can I help you? Look for trains. You provided a source and destination, and then you finally got the list of all the trains. So a story that would fit the conversation flow of this conversation would be user saying greet, the bot replying with the utter greet. So bot replying with a greeting of its own. The user presenting an utterance with the intent search. The bot starts the train form. The train form requires a source and destination. So the bot asks for the source and the destination. Finally, the form is executed, and then the utterance, the reply from the bot happens, and then the user said goodbye, and the bot utters similarly. This is an example of Rasa X interface. It's a proprietary interface. Unlike Rasa, which is open source, this is not open source. So as you can see, the bot is conversing with the user in Hindi, again with the train search example. This is an image of the Facebook integration part, where we are searching for the information regarding the train number 12401. So we write 12401 के बारे में जानकारी दें. The bot replies with the information regarding the train, and it asks that if you have any other query, and then the user again asks for schedule. So you can have multiple tasks in a single conversation, and the bot replies with the schedule of the train starting from Islampur and then going to the next stations. Similarly for WhatsApp, so WhatsApp, again we see that the user asks क्या 2AC उपलब्ध है ट्रेन 12401 में, and the bot replies yes, the particular coach is available in this train, so AC 2 tier coach available है. Then we ask if any particular train has been rescheduled on a particular day, so इस तारीख को पुनर्निर्धारित train दिखाएं, so the bot replies with no train has been rescheduled for today. Similarly, we can ask for whether at what time a particular train reaches at a particular station. So कितने बजे train 12401 दिल्ली पहुंचती है. So the bot replies गाड़ी संख्या 12401. Since it is looking for a database, it still responds with English for that part. So New Delhi पे 11:50 बजे पहुंचती है. कृपया अपनी query बताएं. So it keeps asking for if you have any other queries. The user replies with no or goodbye, and the conversation ends for this. So now we'll be moving on to demo. Hello, is this screen visible?
Yes, yes.
Right, is the text legible? Or should I zoom up?
Yeah, little bit. Yeah, good.
It's better, right? Okay, so first we'll be going over the WhatsApp interface. So WhatsApp interface, in order to deploy our chatbot on WhatsApp, we require a business account. Since we don't have a business account, we are using a service provided by a company called Twilio, where we are using an extra hop for our server to connect to our the WhatsApp. Right. So because of this, in general, the process tends to be a little slower than normal. So let's start. We start the conversation with something like Delhi से Mumbai की trains दिखाओ. So the bot replies with there are 12 trains available, 12 trains available, and these are the train numbers and train names. So let's say we are interested in this particular train 12472. So we ask 12472 के बारे में जानकारी दें. So it shows that the train name is Swaraj Express, and it starts from Jammu Tawi at this particular time, reaching Bandra terminus at this particular time. Let's say we are interested not only in the first and the last station, but we are interested in the entire timetable of the particular train. So we say something like 12472 ka timetable dikhao. So it gives the entire timetable of the train. Now, as we mentioned in the during the presentation, the Rasa uses something called a tracker, right? So the tracker holds information across multiple utterances. So moving onwards, we don't need to provide the slot values of source, destination, and the train number. The bot should be able to handle it by itself, right? So we can just ask for if a particular, like train में pantry car available है क्या? So we don't need to provide the train number since we have already provided the train number in previous query. So train में pantry car available है. Now, not only we have provided the train number, we have also provided the source and the destination. So we can just ask किराया कितना है 2AC का, and it should give me the fare of 2AC in train number 12472 from the Delhi to Mumbai, right? So it gives the fare of all fare starting from the 2AC, but it also gives the fare of all the other options available. So we can also ask S11 coach किस position पे है train 12472 में. Now, since I mentioned that the train number is also provided, so we don't necessarily need to give it. So we go for if a particular coach is available in a particular train. So it says that आपका coach engine से 5वें number पे है. Now we can check whether the reply is actually correct or not. So we go ask for the entire coach layout of the train, and it replies with the entire coach layout of the train, and we can see that S11 is at the 6th position, 5th from the engine, as mentioned in the previous reply. So this is a basic demo of the English chatbot. Now we'll showcase our web interface where something like we will be showcasing the English version of the chatbot. So we ask, we say the user query hello, and the bot replies with whatever the list of all the tasks it can perform. Again, we'll follow a similar conversational structure. We'll start with the show me trains available from Patna to Delhi. So basically the same train search. As you can see, the process of conversing is quite faster on the server because for WhatsApp we are using multiple hops. So there are around 8 hops for WhatsApp, while running on server we are only facing 4 hops. So let's say again we are interested in the train number 14003 and we ask for the information about this particular train. And we get the details of the train where it is NFK and DLS Express, its starting and ending. Again, we want not only the starting and ending but entire schedule of the train. So we ask for the schedule and it gives me the entire schedule of the train starting from Malda town reaching New Delhi. Also, we can check whether a particular coach type is available in train. So is sleeper available? As we have already given the train number, it should work directly. So it replies with sleeper coach is available. Also, we can just ask what is the fare. We have already provided that our preferred coach type is sleeper. Our train number is 14003 and our source and destination are Patna and Delhi. So it gives the fare starting from sleeper, that is the one that we have mentioned in the previous query. Coach position of S3, similarly we can ask whether at what position sleeper third coach is available in the train, and says that it is from the 13th number from the front. We can verify by checking the entire coach layout. So checking the coach layout, we see that S3 at the 14th position, which is 13th from the station, from the engine. Now that we have tested for English, we'll go with the Hindi version. Okay. So we start with a greeting of our own, and bot replies with a list of tasks it can perform. We will do the same task done in the previous showcase to maintain some degree of coherence. So we ask with क्या कोई ट्रेन पटना से नई दिल्ली के बीच में उपलब्ध है, and it will show the 15 trains available. विवरण बताएं ट्रेन नंबर. Let's see. We want the information of a particular train. Train number 12349. It should be this one. So it should give me Bhagalpur NDLS Express. It starts at Bhagalpur to New Delhi. Again, for particular coach availability, a common cast question, like sorry, not particular coach availability, a particular coach position. So where will a particular coach come in the train? So it says that S3 coach ट्रेन में इंजन से चौथे स्थान पे है. कोच लेआउट देखना है ट्रेन का, so we can verify that our response is correct or not. So it says इंजन से फोर्थ स्थान पे है, and it is at the fifth position, which is basically fourth from the first. Finally, we can also go for similarly fare like we did for the previous queries. So we can just go for kiraya kitna hai, and since we have already provided the source, destination and the train number, it should just give the fare. So sleeper kiraya 498, 1 AC, 3, 2 AC, 3 AC. So this is most of the demo. Since we have already shot over time, I'll try to give just one more language. So I'm not sure if all of you get it, but a simple demo of trains Benglish bot, so Bengali English code mix, and we can just ask the chatbot Bangalore থেকে হাওড়া অবধি কি ট্রেন আছে, and it searches for train. It says that 3 trains are available: Dilbara Express, Guwahati Express, Mass Howrah Express, and we can just repeat the entire process that we have shown in our previous examples, and then it will perform similarly. Resets, okay. Anyway, that's all for the demo. We have already shot over the time, but if you have any queries, feel free to ask. Okay, then I think that's nobody. No, it's blocking.
Hello, sir. Good evening. Hello.
Sir.
Sir, I wanted to ask. Actually, I missed the starting part. I just wanted to ask this data, whichever you're retrieving here. So, is there any relational database in the backend?
There's a non-relational database that we are using called MongoDB.
Okay.
Right. But the main idea of that is that we are just storing the data that we are getting from the conversation, so we can use it again to retrain.
Okay. Okay, sir. It can be possible with relational databases as well, right?
It should be possible, but we didn't have any use for that for our case.
Okay. So, okay, sir. Thank you.
Okay, then if there are not any questions, I'll transfer to Jishan sir. Right. And for questions, you can keep answering the question in the chat. Okay.
Okay. Okay. I think yeah, someone have to give the permission to share. You got the permission?
Hello. Yeah, sure. Should I share my
Hello. Hello, sir.
Yeah.
Can
Yes, Jishan can share, no?
Okay, sir. Is my screen visible?
Yes, Jishan.
Yes, Jishan, it's visible.
Okay. Yeah. Hello, everyone. I'm Zishan Ahmed.
Your voice is very low.
Okay.
No,
Hello,
it's
everyone.
okay.
I'm Zishan Ahmed and a research scholar at AI NLP ML Lab working under Dr. Asif Iqbal. So I'll be going through encoder-decoder models in deep learning. So these have become very prevalent nowadays for building chatbots and other text generation systems. So yeah. So we'll go through the types of deep learning model, some basic overview, the basic idea behind the encoder-decoder models. Then we'll move on towards encoder-decoder model, their implementation, and we'll also discuss about teacher forcing and creative decoding methods. So yeah. So we can broadly categorize deep learning models based on the number of inputs and outputs. So we can categorize them into 4 categories: one-to-one, many-to-one, one-to-many, and many-to-many. So one-to-one is a simple, could be visualized as a simple image classification model. One-to-many can be visualized as image captioning model. Many-to-one could be a simple text classification model, and many-to-many could be both text generation and sequence labeling. So encoder-decoder models comes under many-to-many model. So we have multiple sequences as input, namely sentence, and we have to generate another sentence. So we have an utterance as input and response as output in case of chatbots. And another many-to-many model is sequence labeling, and one example of that is pause tagging or named entity extraction. But we'll discuss on many-to-many encoder-decoder models for text. So yeah. So as the name says, the model consists of an encoder and a decoder. So encoder takes a sequence of tokens as input, and this input could be an utterance in a dialogue, and encodes them into hidden states. So hidden states are matrices, matrix representation of the input sentence, which was in form of embeddings. The decoder takes this hidden states and produces a sequential output, and these outputs are finally converted to text outputs. So we'll go through how this entire process works. So an encoder for text is usually an RNN cell, uh, like LSTM or GRU unit. So LSTM is long short-term memory, and GRU is gated recurrent unit. And an encoder takes input sequence and encapsulate the information as internal state vectors. Yeah. So LSTM and GRU takes only one element at a time. So at one step, we pass one word, we get its output representation, hidden state and cell state, and hidden state and cell states are passed on to the cell state is stored as a cell state. Hidden state is passed on to the as a next input to the LSTM model, and a next token is taken. And this is how this LSTM model or GRU model unfolds across time. So yeah, for so these are the basic steps for encoder. So this is just an encoder representation, which is simply a GRU or LSTM unit. Uh, so yeah, so we'll just go through PyTorch code for this. Uh, so we define the class encoder RNN. So here this RNN is a GRU unit. So and also we have an embedding, so which converts uh, words um, into into vectors, which are known as word embeddings. So uh, so whatever input we get is converted to embedding, and then we have another GRU unit in the same class. So input is passed to embeddings, and embeddings of words are obtained. And then these embedded representations is passed to GRU unit to obtain the hidden representation. And finally, this forward pass returns the output and the hidden state. Uh, so this is how the encoder is coded in PyTorch. The second step is the decoder. So in the decoder, we take the hidden state and cell state from the encoder and initialize the decoder's hidden state and cell state uh, with that with the encoder's hidden state and cell state. So this is done to pass to inform the model, inform the decoder model of what was encoded. What, for example, if we have in case of chatbots, we have some utterance. So the utterance is encoded by the encoder, and the decoder should know that what was the utterance. So this is passed in form of hidden state and cell state, uh, and then the decoding takes place. Now decoder again is an RNN unit. It could be LSTM or GRU, and we pass a start token uh, initially. So when the decoder looks at start token, it gets a signal that it should start decoding, and its decoding is based on the on the hidden state and cell state, which is the encoded representation of the utterance. And the model generates the first word. So I is generated here. Now this hidden state and cell state is again passed here, and I is given as input, uh, and then the next word is generated, and so on. The decoder unfolds. So yeah. So again, the initial states of initial state, that is hidden and cell state of decoder, is set to final states of the decoder. And first we input the start symbol as we saw, and then the model also learns to predict the end symbol, because we have to append end token uh, at the output side, at the end of the output side. So so the model hello. Okay.
No. That's sufficient. Even if you would not send, then also that's okay. Already the records are, you have filled the form, no? That registration form. That's all. That's all. We will get everything from there only. And now the course is too long. Your number is anyway. I have
So the
stored.
model learns to produce the end symbol because we create a data set in such a way that the output at the end of every output, an end symbol has to be generated. And finally, loss is computed on predicted outputs for each time step, and this is usually a negative log likelihood loss or cross entropy loss. And then the errors are backpropagated through time to update the parameters of the model. So this is the basic functioning of a decoder, and this is again the implementation of decoder in PyTorch. So it follows pretty much the same approach, same class as the encoder. The only thing here is that apart from embedding and the recurrent unit, which is GRU here, we also have a linear layer, which maps the hidden state of the decoder to the output size. Now, output size is the set of is the vocab size or vocabulary size of vocabulary. The number of unique words there is in the entire conversation. That is the size of the output. And finally, this is mapped to probability distribution by using a log softmax. And in forward pass again, we get the embedding representation of the input, and we have um, a ReLU uh, activation after this on the outputs. And we pass the hidden state of the RNN of the encoder to GRU, and we also pass the output to obtain the uh, yeah. So that next word could be generated, and finally again this is reduced to probability distribution the output, and the output and hidden states are returned. So so this is the encoder decoder model in short. So it consists of encoder and decoder. So here we have how are you as an occurrence. So this is encoded in as a hidden representation, and then I am fine is generated as the output by decoder based on the hidden representation that the encoder produces. Uh, so next is teacher forcing. So this is done during the time of training. Teacher forcing is a training mechanism where it is assumed that at each step t during decoding, the model is giving correct output. So therefore, at the next step, that is t plus 1, the input to the decoder is given as the gold label token and not the predicate token at time step t. So so here, suppose the gold output is I am fine, then we assume that whatever the decoder is decoding is the correct output. Uh, we assume that the decoder is decoding the correct output, and therefore we do not bother to look into the output that the decoder is generating. We simply feed the correct output at the next time step, and we keep on generating that way. This is done during training, and this is called teacher forcing. So, uh, as you saw, teacher forcing is done during training. So here we can see that the decoder input is uh, uh, at the start. It is just a start of sentence token, and during teacher forcing, uh, yeah, we directly pass the outputs into the decoder input. So and we do not bother about uh, taking the passing the previous steps output during decoding. So
ये चार्जर इसका
so
चार्जर चार्जर देना लगा के उधर से
so
ये ना
this
एग्जाम
is
वो है ना कि
greedy decoding. Greedy
हेल्थ
decoding
लगा
is done
Talking.
during.
Yes, yes. Dishani, continue, please.
Okay.
So others, please mute.
Uh, so greedy decoding is done during the time of evaluation. Now, since we do not know the gold token at time step t during evaluation, uh, we know that during training, but we do not know this during evaluation. So what we do is we take the token produced by decoder at time step t as input to decoder at time step t plus 1. Uh, so, uh, and the token selected at time step t is by taking Rmax over the probability distribution of the vocab at the output. So, uh, so this is how greedy recoding works. So instead of taking the uh, yeah instead of assuming the output to be correct, we actually have to pass the generated output at time step t for decoding of the next uh, token at time step t plus 1. And so this is as shown, this is done during evaluation. So we have uh, so here we can see uh, at during time step. Wait. We append the decoded words in. We keep a list of decoded words, and we pass it again during decoding to decode the next word. So as you can see, this is done during evaluation. So since we do not know the gold label here, and we need to generate it during the runtime. So these are this is how encoder decoder model works. Uh, so this was the basics of the functioning. So thank you. Any questions?
Sir,
Yes.
is the encoder decoder model is using for the sequence labeling task like post tagging?
You could use it for sequence labeling, but it's usually not used. Uh, it could be used actually. Nowadays we have very powerful language models like BERT and GPT especially. So it can be used for sequence labeling also. Uh, uh,
Hello,
and-
sir.
yeah, hello.
Can you tell something about BERT?
Okay. Uh, BERT is the encoder part of transformer. Do you know what transformer models?
Little bit.
Okay. So transformer is also an encoder-decoder model based purely on self-attention and cross-attention.
Yes.
So it was proposed, it was written in the paper, attention is all you need. So BERT only takes the encoder portion of the transformer. And
Okay.
what it does is, it does a sequence labeling kind of task, which is self-supervised to get contextual word embeddings. What is it? So this happens. So what they do is they take a sentence and randomly mask some tokens with a 15% probability. Uh, uh, randomly mask some of the words in that sentence. And since they already knew what the original sentence was, right, they try to regenerate it. They give the masked sentence at the input to the encoder, right, uh, and then try to regenerate the original sequence. So the model learns to uh, produce the original word in place of the mask tokens. Are you getting my point?
Yes, yes, but
Okay.
some
Yeah.
sentences are taken initially. So some means what? I mean, quantify.
No, you can, since some meaning, you can pick up any sentence, right? They pick up a
I
huge
mean,
amount of corpus.
usually in deep learning that we consider large number of data. I mean,
Yeah,
the
yeah.
size
Since
of the
since it
data
is
is
completely since it is completely unsupervised, you do not need parallel data, right?
okay.
So you can do this on any data dump, right? You do not need an annotated data at all uh, to create to get this BERT embeddings. So what they have done is they have taken Wikipedia dump, right, and they mask random words in sentences, right? So they have this, and they create this parallel pair. So they take a sentence and they mask certain words. So they have the masked version of the sentence and the original version of the sentence, right? They
Okay.
give the masked version of the sentence as input and try to regenerate the original version
Means they have
at the output.
mask available.
No, they mask it, right?
They mask.
Randomly they
Okay.
mask it.
Okay.
So so this is how. So what they are teaching the model to do is by masking random words in between, they are asking the model to guess the word by looking at its context, right?
Okay.
So it learns to guess the word by looking at the words that are before
Surrounding
and after
word.
it. Yeah, surrounding words.
Surrounding. Okay.
So that is why it's called contextual embedding. Okay.
Okay. Thank you.
Yeah. So, okay. Any other questions?
Thank you, Jisan. So
Yeah.
nice to hear you after a long time.
Thank you, sir. Nice to hear from you too. Yes.
So implementation, Jishan, do you have anything?
Sir, I have given some codes in the presentation, but I have also trained a model.
In fact, Asif, yesterday there were a lot of questions and lot of people are really interested in Indian languages.
Okay.
So like the basic problem what they discussed yesterday with me was like post tagging and then embedding, how to embed Indian languages and how to do basic operations in Indian languages. Once that is done, then they can use it for other deep learning models also. So if you
Right.
can share with them some of the resources or some
Okay.
links where they can really search on that.
In Indian language, right? Yes.
For Indian languages, like especially Hindi, Marathi, uh, most of them were talking about those things. So if you can just give certain links to them.
Okay,
that
okay,
would be
sure.
helpful.
Okay, I'll forward you.
Okay, so just please forward
Excuse
me.
me, sir.
Yes.
Sir, the main problem which we means I have done the work in word sense disambiguation for Marathi language for my PhD. So the main problem I faced was the tagged data set was not available that time. Only two corpus were available. That was health domain and tourism domain.
Yes. When did you finish your PhD, madam?
2018.
Oh,
So that time
2018.
IIT Bombay has helped me. Dr. Pushpak Bhattacharya sir has helped me a lot with that data. He only opened it for research purpose. Yes. So the main challenge is the tag data is not available for these
No,
languages.
for many Indian language resources.
Yes, yes.
So if you see our web page also, that AI NLP machine learning web page. Okay, so AI, if you search in the Google, so in the download, this one can you type in, because I don't know why it is not opening this site. AI NLP
Okay.
machine learning homepage, and then can you show that downloadable option? So there are quite a few datasets.
Okay. Yes.
Resources, no? That,
Yes,
no,
yes,
no,
it's
no,
not opening.
downloadable. So this is one. There are other we can curate also. So can you? Oh, this is not opening.
No, sir.
No, no, it will open. You are. I don't know. You are.
Okay, let me try.
I think can you try outside network? I think
Yes, sir.
Sir,
there are some
it is
issues.
working, sir. It is working. I
It
can
will not.
see.
Yes, can you go to the download? Probably, I think resources download. All these resources, and there are.
So yes, there are resources.
There you can see a lot of resources, and many of them are Indian languages also. Okay.
So I'm just pasting that to chat window. So those who were really asking these questions to me yesterday. So as I promised yesterday also that a lot of these questions will be answered and can be boldly answered by Dr. Asif. So please go through these resources and
And also there are other groups, for example, IIT Bombay, what date is there, right? So CFIeld website, you can also see. And then IIIT Hyderabad LTRC, right? So LTRC, IIIT Hyderabad, CFIeld,
Yes,
CFILT,
LTRC also has got good contribution in these Indian languages.
You can see this. So along with us, we actually periodically we are now releasing all the resources. Okay, very. So this is one of our. We have a dedicated student group. So who actually makes sure that all the resources, if there is no copyright issue, for example, there are suicidal note analysis, there are some sensitive documents that we cannot really release, but for the other resources in Indian languages and also English we are releasing. So you can see our AINLP machine learning group, LTRC you can see IIIT Hyderabad, CFILT IIT Bombay. Speech if you want to see, then you have to see IIT Madras speech processing group, And also you can see that TDIL, okay, TDIL Meiti for Indian languages, okay. This website you see. So I'm typing all these, okay. So you can note. I'm writing in the chat box. So TDIL Meiti is this. Then there are CILL. Probably you know, right? Mysore. This you can see. So TDI, let me see TDIL exact link. I can send you TDIL. Okay, so there are, I think, this one. You see that free language softwares and tools. If you open this TDIL, this particular site, okay. So I have typed in. Then you can see this. Now CILL Mysore also has resources.
Sir, please share these links in the.
I'm
channel feed.
writing in the chat box. Can you type everything that I'm writing there? Huh? In the chat box, you can see this. Huh?
Check the chat box of the WebEx window.
That I am typing there. Huh? I have already typed in quite a few, so you can see from this. Huh? And then, okay, let me see this one. So why it is not opening? LDCIL, can you open? Linguistic Data Consortium for Indian Languages. It is not opening in this my. Okay, let me see. LDCIL, right? No. I think they don't give resources. So again, I'm typing another link. So please see all these. Okay. So this LDCIL. You see, open it. Then there are resources. Okay, you'll see the text resources, etc. Text corpora, compatible text corpora, speech corpora, sign language corpora. So all these are there. Okay, CIL, LDCIL. Okay, Linguistic Data Consortium for Indian Languages. So I think these are you'll get a lot of resources these days. So, but for example, yes. So still. For many languages, particularly Hindi, Hindi will get quite a few resources for part of speech tagging, named entities. You will also get sentiment. We have our own data. We have released it for different domains. We also have data for translation and others. And you can check periodically these websites. Okay, so our websites also periodically we actually keep on uploading all the resources. Then LTRC, CFILD, then this TDIL of Meiti, Ministry of Information Technology, Technology Development in Indian Languages. Then this LDCIL. Okay, so these are the sources where you can get the Indian language resources. Mainly.
So thank you, Dr. Asif.
Yes. If you have any questions, then probably I can take it. Dishan, you were saying something. So about this implementations, Dishan?
Yes, sir. Yes, sir.
Please
So
complete it quickly.
Sir, may I ask a question, sir?
Yes.
After this session only, we will have the quiz, no?
Quiz is already active. So after
Oh,
this session, you can just finish it. We will give sufficient time. Don't worry about
yes, yes, sir. Thank you.
Sir, I'm working with Indian languages, for example, Bengali or Assamese. So my work is mainly on the speech recognized text. So there was one question. Is that suppose, for example, I have to stem some words to tokenize or anything. So just normal stemming does not work because like the English, the library, NLTK library, they don't work. So I use INLTK. So in case a word is not stemmed properly, so that in that case, what are the steps that I should follow to get a proper words, for example?
So you have a problem with the stemmer that you are saying?
Yes, that is one problem is with the stemmer, and second problem is that, for example, for Bengali, speech recognized text are not up to the mark. Too much of word error rate. So, for example, if I want to go for any sentiment analysis or summarization, for example, it gives a lot of performance error. My goal is to not to improve the ASR, but to bypass that need of depending on ASR and to work with text in such a way so that we can at least have a reasonable, sufficient result. So,
Okay.
yes, sir.
No, but ultimately you are working with a speech input, right? Or
Yes,
the
sir.
input can be text also.
As input can be text, but basically speech input, sir.
So if it is a input the speech, then you should have a ASR, okay, automatic speech recognition. Otherwise, you cannot really do anything.
Yes, I have an ASR with a faulty ASR.
I know. So because in Bangla you don't have lot of let's say speech corpora in Bangla where the model can be trained. Okay, so I think quality is not good. That we know because
Yes.
IIT Madras also. I think CDAC Calcutta was doing this for a long time. Okay, earlier maybe long back 2006 or so. So recently there is a kind of speech-to-speech machine translation activities because of this new education policy, right? Where you have to translate all the educational contents from English to Indian language. So as part of that, there is an initiative to develop the ASR. Okay, but for Bangla, unfortunately, so far the good ASR for Bangla is not available. Okay, so IIT Madras mainly is coordinating on this. Hindi is there, Telugu is also there.
Yes.
Bangla also, for example, ASR.
It's there, but very subpar.
Problem for our chatbot also. This chatbot that Ratnesh Kitiz and Aijan was showing. So they are also we are supposed to have a speech input. Okay, for Bangla also we have the same problem. But Kitiz, what we are using some open source ASR we are using, right? Ratnesh, are you there?
Yes, sir, they are using Mozilla Deep Speech.
But Bangla, it was very, very bad, no? Last time
Yes,
we
sir.
saw.
It was the worst of the bunch.
Bangla was yesterday only we were checking with this Bangla with Mozilla. They have made it available, but actually
I
the
was working
quality
with
is very
Google
bad.
Cloud ASR. So in that case, what happens? Suppose I have, for example, I have a news session of a broadcast news session of for say 10 minutes. So it is unable to recognize the entire audio but it can only recognize the first few seconds. But if I segment that into some sentence level or suppose some seconds frame, then it is able to recognize each of these segment and then but even then there are errors. So my query was that instead of depending on completely on ASR errors, is there any way where say embedding, because I saw in INLTK package I have been relying heavily on INLTK, so there is this embedding function will that help overcome this challenge of wrong recognized words? Is that
No,
possible?
because the ASR output is wrong. So if the ASR output is wrong, then you really cannot have any way. So uh, mm, because original text you are not able to generate, right? Because a lot of words are having the problem.
Right.
So now this word embedding would be useful, or the in a sense that basically it gives a representation. Every word will be represented as a vector in the semantic space. Okay, so and then the other one, for example, in case of character embedding is there, where even if you don't have a good stemmer, so you can do some kind of, let's say, character embedding you can use. Okay, so rather than word embedding, character embedding might be useful. So nowadays in deep learning model, people generally don't use any stemmer, so we don't worry about stemmer. Rather, you do this. Okay.
Right.
So, but the problem with that the ASR output itself is not of good quality, and you have no way to get the original, let's say, original text document, right? Because ultimately your input the speech, and the speech is converted into ASR text, and from the text actually you are processing. Now in this conversation, in this conversion, you have a lot of errors that you are saying, right? So uh, this is a problem with ASR. At this moment, you cannot really. You have to improve the ASR for otherwise it will be a problem.
So I have been actually wondering that for other languages, suppose not Indian languages, say, but other languages, their applications are developing in a fast pace, but we are still depending on developing in the ASR and then catching up to that level of state of the art. So I had been like, that was my motivation, as in if there were any such tasks or applications which can be this entire dependency on ASRs could be bypassed, and some text methods, maybe embedding or anything like that, if that could be, if there was any solution like that, then it would have been much helpful for low resource languages like our languages.
No, but ultimately, if there is a speech as an input, okay, or audio, let's say some video or audio is running, then you need a kind of descriptions, okay, like we do in image. So then rather than image processing, if you know it is wrong, then maybe the image description, so that you have, okay, that might be only the textual descriptions, that may be useful. So in this case, if you have, let's say, when but in this case it will be difficult because you are speaking, and at that time, let's say, if there is a caption is being generated, whatever you are talking, okay, if that is possible, if there is a caption also available, then you can ignore that ASR part. You don't have to worry about this conversion, okay. But again, this I think is difficult to bypass, because you have to deal with this. Only you can do is that you have to because ultimately your input is noisy, because output is noisy, so there will be a lot of disfluency. Okay, so so disfluency handling in speech, okay, there are standard ways of doing that. Now as there are a lot of errors, so you can train the deep learning model with the noisy text as an input. Okay, noisy text means, let's say, and then your target will be to generate the original text. Okay, so it is a kind of, you know, that there is a sentence, and in the sentence maybe some suffixes are missing, some prefixes are missing in a word. So you can randomly make this kind of changes, and you can introduce the noise in the text. Okay. Well, not necessarily the ASR output. Let's say if you know there is a standard Bangla data sets available, news corpus, for example, and then you introduce the noise in the Bangla sentences, and you also know their original sentences, actual ground truth, basically. So you can train a kind of model. Okay, the input to the model will be this noisy sentence, and the output will be the actual sentence. Okay. Now, if you get an ASR output which you believe is noisy, okay, is not correct, So
Hmm.
that can be used as a testing set. Okay.
Hmm.
And then that is the only way. So by you train your deep learning model with a noisy input, and then you do this. Okay, so that way only you can handle the situation. So but ultimately you have to change this. Okay, so otherwise there is no options. Huh?
Right. Thank you so much, sir. That is a very good idea, sir. Thank you.
Jishan, are you going to demonstrate something more?
Yeah, Jishan, quickly can you show? Jishan? Jishan? Hello, Jishan.
Hello. Yes,
Can
sir.
you quickly show this?
Okay. Yes, sir. So in the presentation, I had given some codes for encoder-decoder model. So I have trained a model based on the same codes. So I'll probably share the link to the presentation also. So it was trained on, I think, COVID dataset. So here, if I say I have fever, then yeah, this is the output. Like you have got borderline high hemoglobin as well, better take aspirin and these things. So similarly, like for input, thank you doctor. What is the safest way to take the IU vitamin D for the next 10 days? So like you can take it once a day. Yes, you can do pranayama at home. So I think yeah, it's asking about yoga also. So as we can say that this simple model uh, can be used to generate generate good responses. Uh, but the only problem is that it's very hard to control them, especially in open domain. So so encode decode models are the starting point for for a chatbot, be it task oriented or non-task oriented or open domain. But then we also have to give a lot of control factors along with it to be able to control the conversations where it's heading. So yeah, the, uh, so this is all actually. So I'll share the uh, presentation link, and through that code, you can also build the model on and train it on any data set. So this was all actually.
Thank you, Jishan. And thank
Thank you, sir.
you, Dr. Asif. Thanks for your time and your expertise. In fact, we have a lot of thanks and positive feedback from the users, from all the participants. So the credit goes to our experts, our really the people have appreciated all the expert sessions mostly. So thanks. And now I can really, so we have our other coordinators available, Dr. Atul Gupta, Dr.
Okay,
Namita Mittal.
so maybe we can sign out, right? Yeah.
Asif, if you want, you can sign out also.
Okay.
Okay. So thank you, Asif.
No, we can stay. So do we need? So we have to sign out or what? Maybe
So
we
if
can
you
stay for some.
stay, you say people, we can just have a
Okay.
discussion with
So
the
I'm staying for
participants.
some more time. Okay.
Yes. We will just get some feedback from the user because this is the last day. So how they felt about, and in future, if we are planning to have a course like this, what sort of improvements we can do. So, Namita ma'am. So I think, are you there? You there?
Yes. Good evening, sir.
Good evening. Atul sir.
Yes, Dr. JP. Yeah, we can go ahead with the participant feedback straight away. I mean, obviously it was a fantastic program, but then yes, let's hear from participants. That will be the best idea.
So I will request the participant, as suggested by Atul sir and Amita ma'am also, that they should say, already they have given the written feedback, but if they can say something, in what way probably we can improve on this. I know that we had some issues, like Canvas was one issue, And then sometimes we have to alter the sessions also due to unavailability of the experts. But overall, it's a long session, 15 days workshop. Some things goes beyond sometimes. So, but still, how is we can improve on this? These things are already noted. So to our participants, if you can.
Sir, may I?
Yes, sure.
Yeah, myself.